Hello. Hi, everyone. Good morning. How are you? Mike is doing good today. That's good. Thank you so much for being here. I really appreciate it. First, because it's super early. And yes, I'm not a morning person, so I appreciate your being here with this good energy. And also, at the exact same time, there are 3 other amazing talks by amazing speakers and people, friends of mine. So thank you for choosing to be here. And probably we'll have some viewing party in order to not miss the rest. So let me know if you want to join. Today, I am going to talk about Kotlin Multiplatform. If you were at the keynote before, you heard a lot about that. And this conference would have a lot of talks about multi-platform in general, libraries that you can use, specific parts of it that I'll mention through this talk. But this is a very high-level introductory talk. So I will mention a little bit after the other talks in this conference that you can go to in order to go deep dive into specific parts. But if this is the first time you hear about Kotlin Multiplatform, if you heard about it but didn't start working, are not sure if you want to do that or not, if you're just started to explore anything like that, that would give you a high-level overview about what it is and why should you maybe start looking at it. Yeah, so this is kind of to set the expectations to what this thing is. So, hi again. My name is Britt, Barak. Haven't introduced myself before. I work for a company called Nexmo that was acquired by Vonage. So now I work for Vonage, I guess, and we have a lot of communication services. So like APIs at SDK for SMS, phone calls, IP calls, WhatsApp, video calls, all this kind of stuff. I manage our conversations products. So it's an omnichannel product for all of these channels together that we have. Oh, it's got dark. So romantic. So we have. So I manage our conversation products that we have Android, iOS, JS, SDK, and a backend API that essentially allows you to do all of these different communication channels together with one product. And then also we keep the context, the events, in order to that you can do cool and interesting conclusions on this communication interactions. So as you can understand, we have a lot of different platforms that we work on in the same team. This is just a few of the wonderful engineers that I get to work with every day. Yeah, so we have one product, but a lot of different platforms that we want and need and do support. So this is kind of what we got into looking at multi-platform and started to work with it. More about that in a few minutes. So this is part of my team with one exception. And actually, I think maybe the favorite person in this team is this lady called Emma. She's one of my really best friends. She's an amazing mobile engineer. A few months ago, she decided to leave the team. And as all of us are really good friends, we decided to throw her a really cool goodbye party. The thing is that my team, as amazing as it is, we're super good at writing software, not very good at organizing parties. So we decided to write an app, obviously, with our product, our SDKs, in order to organize this goodbye party for Emma. So the app is going to look something like this. This is like the different tasks or like different items that we need to buy. So each person in the team can add different items like balloon, drinks, things like that that we need to get. And then each person gets an item or each item gets a person who's in charge of it. And for each item, though, we want to collaborate and help each other to organize. So for each item, we do like this. Anyone in the team can communicate about it. So we can write messages. Jorgo is in charge of the balloons, but I can tell him, hey, if you find red, these are the best type, the best color, and then he can send message backs. All of us can see the messages. We can send photos, and also we can do phone calls and things like that. So this is kind of the app that we wanted to create. Now, as I mentioned, we're going to use our platform in order to do it. And in our platform, the data model, so in our backend, the data model looks something like this. We have a conversation object, which is a conversation in the very essence of it is a container of members who are the people who take part in the conversation, in this case, the team. And a list of events, communication events, interactions between the people in the team, the different items, the phone calls, all of that are different events. In our data model, we save the events chronologically. So we have a list of events ordered by the time they were sent. But as we saw, this is not exactly what I want to do in the app. This is not how I really want to present it. So what we would need to do is to take this list of events and then to sort them, right, in order to present them in the way that we want it. So this is kind of how the app is going to be designed, let's say, or this is what's going to happen in the code. In a very high level, we'll have somewhere a callback, an on-new event, for example, callback, that whenever we get a new event, so whenever someone sends any new event, a phone call, a message, an item added to the list, anything like that, we'll get the item, we'll get the event. Then we would need to parse it, right, to understand which type of event is it. And then we would need to sort it in order to know where to present it. We would need to understand where should it be in the list of the presentation. And then we will present it on the app itself. So if I think a little bit about the architecture of my app, I know all of you do as well, then I would probably want to separate the logic, so in this case, the parsing and the sorting, which is kind of the logic, the brain, it doesn't really need to have a platform-specific code, and the presentation, which, if I'm talking in this case about Android, it has to be an Android-specific code, like the views and so on are like very Android-specific things. So I would probably, in one way or another, would want to separate it to make my app, the architecture, robust and testable and so on. So probably that's what I would do. You can guess, probably you already guessed, that Android app would not be enough for us because we all have different type of technologies and different type of phones that we want to use. In this case, we would want to have the same app, the same functionality, also for iOS and for JavaScript, for the web. And if we would start to write those applications, we would probably do something that is kind of the same, right? The presentation, yeah, it would be different because the browser is different than how the iOS app works and present the views and so on. So the presentation would be specific and different. And then I would also want to separate this from the logic or from the parsing and sorting in this case. But from the logic, I would want to separate those anyway. And if we think about it for a second, anything that is not the platform-specific row, so all of the logic row, it does kind of the same thing, right? So the language may be different, but the whole reason for us to separate the platform components from the non-platform components are like, that's what we did. So it worked kind of the same. So it's a different language, but it does kind of the same thing. So how cool would it be if instead of duplicating it, we can have just one component with all this logic that is kind of the same. It can be shared, right? It's a common logic. And this is exactly the idea of Kotlin Multiplatform. So this is what it allows us to do. Two important points. What it allows us to do is to actually share only what you want. So only the code that we want to share, we will share it. And the other code, like here in this case, the presentation, I can also tell you that I told you we do like phone calls and video calls, so you can understand there's a lot of platform-specific things that are going on there. So I can decide what I want to share and what I don't want to share. And also, like, when do we want to share these things? So a lot of people, when first hear about Kotlin Multiplatform, they think about framework like React, like Flutter, Xamarin, this kind of platforms. So a major reason why this is very different is because you don't have to move your entire applications to a different ecosystem, like to a different platform. You can decide when do you want to share, what do you want to share, leave the native and the specific things whenever you want to leave them in the specific platform. I can tell you that for us, it was a big advantage because we already started to work on the SDKs. We didn't want to refactor everything right now. So this allows us to do it in pieces, right? To decide, okay, now we want to do something that is shared, or now we want to refactor, and we can move it to the common model. So that's a very huge advantage that also, I think, gives you a lot of confidence in choosing to play around with it or to start working with it. Okay, so a little bit more about how this works. So the way that Kotlin Multiplatform would allow us to build our applications is to take this logic, the common thing that we wanted to share between the different applications, the different platforms, and to say, okay, this is a common set of source code. We'll see it in a second. But this is a common component, a common library where we have all the shared code in that specific component, that specific place. And then how would we do the separate code? So we would have different targets for each, we call it the target, so for each platform that we want to run on. It is called a target, and a little bit of how it works. So let's start with the Android bit, just for the sake of the example. On our Android devices, where the application run, well, the Android device doesn't really care if you wrote your app in Java or Kotlin or Scala or anything. It doesn't really care. The device has this component called the JVM, the Java Virtual Machine, that knows only how to work with one type of file. And this is the Java bytecode, so classes that end with .class. It knows only how to work with them, to take them and run them, and then you can see your application, in this case, the Android application. So how does the code that we write in Java or Kotlin turns into that, or gets to the JVM? We write our Java code, for example, and then it goes through the Java C, the Java compiler, turns into a Java bytecode file that are sent to the JVM. Same thing, sort of, if we write with Kotlin. So with Kotlin, our Kotlin files would go through the Kotlin compiler that also can read the Java files. And the Kotlin compiler would turn it into Java bytecode that the JVM can understand and can run. And this is how this works for Android. So essentially, we talk a lot about, like it's very common and very popular right now to talk about Android, Kotlin for Android, but what actually happened, it's not necessarily specific for Android, it's for JVM. So the Kotlin has 3 different flavors, and one of them is Kotlin JVM, meaning we can take the Kotlin code, turn it into Java bytecode in order for the JVM to take it and to run it. So this is one type of flavor that we can use. As I mentioned, it's very commonly used for Android, but not only. So any backend or desktop applications that use the JVM, you can use that as well for that case. Another flavor that works kind of the same, in the same manner, but can take the Kotlin files and turn them into JS files that can run on JS, that can run JS applications. Once again, either on the browser or on the backend. So for Node.js, you can do that as well. So it works kind of the same. And the last one, the last target or the last flavor here, is the iOS. It is, once again, very common to think about Kotlin multi-platform where we do Android and iOS. But what happens there, it's not necessarily specific flavor for iOS, but we have a flavor for, we call it Kotlin native, meaning that we can take the Kotlin code, turn it into machine code that later on, if you write an iOS application, you can use it as any other framework with like any other binary code can run on the iOS applications. Yeah, but in addition to that, because it's machine code, in addition to that, you can also use that in order to run desktop native, WebAssembly, Android native, and so on. And yeah, for us, this is that's been very an important point, that it's not only for iOS, you can do a lot of different things with it. Okay, a little bit on how to get started. Well, there's a photo of a cake here, because we're in a party theme, but I'll be honest with you and say that this is not a piece of cake to get started. But I think, though, honestly, this is the most painful part, like just to get started, just to have your first project, from scratch to running with the platforms that you selected. So have a few free hours, let's say, in order to do that. But honestly, I promise you that this would be like the most painful part. And I do believe, and I know that it would get better and better very soon, because we see how much effort JetBrains put in, and the ecosystem as well, like put in the multi-platform technology. So how does it work? How do we get started? So the first thing that you need to do when you open your IntelliJ and start a new project is to add a plugin for the multi-platform. So you add the plugin, you say, hey project, you're now a multi-platform project, congratulations. That's the first thing that you need to do. And the second thing would be to add the targets. So it's the same targets that we talked about before. We do need to decide which targets do we want to run on in order for Kotlin to know what does it need to do, like which where would it need to run on, which bytecodes or machine codes would it need to turn into, and what can we do? How do we do that, and how can we do it? So there's a list of the supported platforms with a name of each platform that we can use and add to the Gradle when we set the targets that we choose. So the JVM, Android, JS, as I mentioned before, the native, these are currently the supported platforms in native. As I mentioned, for us, for example, we knew that we would need to write things for Linux and for macOS and things like that. Yeah, and as we heard, there will be more supported platform super soon. So that's exciting. So all of those, you can actually use them. You need to decide which ones do you want to run on. And then you would go to your Gradle file, open a Kotlin clause, and say, hey, I'm going to run on JVM, Android, and so on. So the JVM, for example, what I have here actually selects the default preset for running on the JVM. What I can do as well for each type of target is like I did with the JS, to give it a name, a specific name. So in this case, Node.js, I give it a name. And then in this class, I can add some configuration or specific things that I want to add when I choose how to run and how would it work. It also means that you can set different names and then like have different targets that are kind of the same type. So so for different JS targets or different native targets, you can actually have multiple of those. You can just set them up like this. So this is one example. For Android, the way it would work is first you would add an Android target. Another thing that you would need to do is to add a plugin that tells the project if it's an application or a library or an SDK that you're writing. So that's something that you need to do, and don't forget and don't miss. And also then later on, you'll have an Android clause, the same one that you use, the Android developers of you here in the room. So you also have that. That's a separate one where you set up your target SDK, min SDK, all of that. You have that as well in a separate clause. Okay, so that was the targets. We said, okay, we're a multi-platform project. Second, we said, okay, we're going to run on this and that targets. The third thing would be to add source sets. So the source sets are the specific assets, the specific dependencies, the specific libraries that we want to use per component or per target. What does it look like? So I'm going to open a source set clause in my build Gradle. I'll have there, so as you saw before, as you see here, we have Android and JVM as an example for targets. I'll also always have a common clause. And there I can add all the dependencies that have to be platform agnostic. Let's see, we'll see an example in a second. Now, what actually happened, it's not just one source set per target. By default, you have two different source sets for default or like production. This is the main. And the other one is test. If you need more flavors, there are more ways that you can do that. You can add more flavors and have more different source sets per target. These are the default ones. So it means that you can separate the dependencies and the assets that you use per testing and for the testing and for the production. This is what it means. And the next thing you would do is you would open the clause and would write like you're used to be writing in Gradle for the ones who know that, adding your dependencies. So as I mentioned before, in the common, anything that is common in the common target, you only can add things that are platform agnostic. So the stdlib, for example, is stdlib common is common, is shared. I'll show you a little bit later how you can find the things that are platform agnostic libraries or packages that you can use. But here you can have the things that are platform agnostics, as I mentioned, and then in each target, you can add the source sets that are specific for the platform, and you can add there whatever you want. So it can be either platform OS specific thing. So like here I'm adding the Android X, so it's a native Android thing that I can add, library that I can add, but I can also add third-party libraries. So the same thing as I would have done with my normal Android app. I can add whatever I want here. like I'm used to. The project structure would be of that sort. So you'll see on your source, you'll have a root folder, a source directory, and then for each source set, you'll be actually able to see a directory with all the files, with everything that you included, the assets and everything in each different file. All right, a little bit about how we communicate, let's say, between these different levels, or between these different components. So how the app can use the common, so how the target or the platform-specific code can talk with the common code. So, as you might guess, this is something that's supposed to, and it actually comes naturally, because this is the whole point, right? We share code. It means that we have to just be able to use it from any specific place that we wanted. So in this example that I showed before, you have the on-new event callback, and then we have the common code, and then we have the platform-specific code. So the platform-specific code can just talk to the common code and just get whatever, use all the methods and do whatever it wants with it, as if it was just a part of that same library. So this is a small example. The code does not really matter here. It just matters, that we'll understand when we see just a relationship and a bit of how it works. So as I mentioned, in the app, we'll have this callback. So I have kind of a listener in the Android case that inside the listener, I have the callback on custom event, or like a new event that comes in. And then I can ask to process the custom event. So the process, remember, it was something that we wanted to share. So in this case, I can just go to the common main directory and implement the method there. And I can use it from the app with the target specific code as if it was just the same and a part of the same code base, because it is. So, so in the common main, I'll have the process custom event. Then I can do whatever I want, whatever I need with a shared code. In this case, for example, as I mentioned, I will parse it. So I have a library for serialization. So here's the JSON serializable, and then I can use here I use the main. I say, okay, I serialize it, and then like I do kind of a sorting. Okay, if it's this kind of event, the item added event, I'll send it to the presenter to do its thing, to handle it as a new item. If this item is a text, for example, like a new message, I would take it, I would sort it in a different way, send it to the presenter that will handle the message. Now, what is this presenter? This presenter is an interface that I can, and this is kind of a good practice to just write these interfaces in the common models, and then, if possible and when possible, to just implement implement it in the different targets and the different methods. So in this case, in my app, I can just implement that, the handle new message, and this is just an example to show you. This is a recycler view that I tell the adapter, hey, please notify, please change the view. So this is a very specific Android code that I can do on my app. I cannot do it in the model. Yeah, I skipped the iOS. The iOS would be the view controller and so on, with very specific platform, specific platform code. Now, what if I want to skip the presenter? What if for some reason I don't want to, or I can't pass a reference to it from the application, from like the specific platform code? What would I do then? Or in other words, how the common code can talk to the app. So before we saw that it's very easy for the app or the target specific code to talk to the common model, but how do I do it the other way around? So if the common model needs to talk to the app and to reference it. So in order to do that, we have this mechanism in Kotlin Multiplatform with two new words that are expect and actual. Let's see a bit how that works. But before that, I want to say just a word about architecture. There are so many different patterns for architecture. This is not a talk about how to architect your app. There are so many different reasons and different needs for different applications, so I'm not here to talk about that. But for many of these patterns, there are some, not for all of them, but for many of them, we will find some structure like this, which I like to think of my app when I architect it, is in one way or another, these three different layers. One is the presentation, the second is the domain, the third is the data. So just a word about what each of these are and how it fits with the multi-platform topic that we talked about, that we're talking about right now. So the presentation, what can you do? It's a very platform-specific code. As we saw, it's when we want to change the views or things like that, it has to be very, very specific for the platform. So the views, the UI models, which are models that this is how I do it at least, that it's models that allow the view, it serves the view in order for the view to be as stupid and as simple as possible. So I have UI models that I create. Those mostly would need to be platform specific. On the other side, we have the data. The data is something that is very objective. This is how I think of it. Something that you, the targets, the apps, cannot really change. So in our case was the conversation data model that I showed you. It comes from the backend. Many times it would come from different services, so not even from your company, that you cannot really change that. So therefore, I think of it as like the objective truth of the reality that we need to work with. So the data, most of it would be on the common code, on the common model. And there we'll have data models and like the conversation, and also repositories, which would help us to do crude create, retrieve, update, and delete methods for the data models. So this is kind of how I think of it. And the domain layer would be the thing that would allow these two layers to talk between one another. So the expect and actual pattern comes here in order to help us talk between those. In the domain layer, I call it use cases, other people call it interactors, but essentially these are the action, the functionality that our apps want to do, mostly. We'll see one example of this use case is to add an item. So we saw the list before, and let's say I want to add a new item to the list of things I want to buy. So once again, it's a very high level. We don't need to focus on the code so much. It's just to understand the idea. Probably what I would have, this is an option, to have something like this. We'll have a button to add a new item, and I'll set a listener to it, and then inside of it, I will take the UI model that I talked about before, and then would execute the add item use case or interactor that I created with this item name, with a new item. So this is how I add a new item that someone created in the application. So what is this add item use case object? What would it contain? In the common library, in the common code, I would say, okay, we're gonna execute a new item, meaning to add a new item with this name. So we're gonna execute it. I don't know why it does this thing. And the way it would happen, it would just create a new JSON, so we'll create the new event, and then send the custom text in this case, or like to add a new item for a text message, for example. Now, what is this send custom text method? This is something that each platform would need to decide. So what I can do in my common model is to say, hey, I'm the common model, expect that each platform, each different target would know and would implement this method, the send custom text method. And then in the Android part, I would need to open the same file. This is an important piece. Like, we would need to add in the same location. So in the Android, I have add item. This is the same file name. And then I would need to implement the method with the same signature with the word actual. So this is the actual implementation of what the common code expected me to do. So this is how I actually send the custom event. So this is just an example. Here I do send text. I use like the platform-specific SDK in this case, and I send a new text. In iOS, we would use the platform-specific SDK, and we would do, in this case, it looks kind of the same. But let's say if I would want to do the same, like SDK with the same functionality for the browser, it would look a little bit different. And in this case, for example, I might not use a native SDK, but I would do a network call to our API, to the backend API, and ask the API, the backend API, to add a new item. So it could be a totally different implementation. And this is what the expect and actual allows us to do. So the most important things here to remember are two things. One, you have to use the same location when you use the expect and actual in the different directories, so in the common and in the different targets. And the second thing, to use the same signature. It means that here it was easy for us to do because the parameter here is a string. So all of the platforms know what's a string and that they can use the string. If you need to use an object, a different object, if it's Kotlin and you can do it in the common code with platform agnostic, it's all good. If not, then you would need to do an expect and actual for the class itself, so for the object itself. All right, we're gonna finish in a few minutes. Just a little of what can you use right now. So, as I mentioned, I don't know if you can, you can say it pretty good in the packages if you look at the packages in the Kotlin documentation, you have these small chips. So you see like right now it's like different dots, colorful dots. If you hover, then each of these dots would tell you which platforms that this package support. So the blue one, the left one, is common. It means that it's platform agnostic. You can use it whenever you want. So that would be helpful for you to understand which type of packages you can use. So that's from the documentation, from the Kotlin documentation. And also there are many, there are libraries, and we see more and more libraries that are being added. Here I used the Kotlin X for doing serialization. You can use coroutines. We use it, I think, as well. SQLDelight for SQL, so for the databases. So you can use it as well already in Ktor, and more and more and more. So you can look at it on GitHub and see there's a lot of new things going on there. So check it out, and the ecosystem is showing us a lot of new libraries and packages all the time. So it's time to be updated. So here you have some sessions from this conference today and tomorrow that you can check out for multi-platform, native, JS, and so on. So if you want to deep dive into any part of the things that we talked about today, you can do that. There's also a hands-on lab in order to help you to get started. That is both today and tomorrow. So if you really want to get started, I do recommend you. As I mentioned, the getting started bit, it's like the configuration, it's the hardest part. So this could be a good opportunity for you to attend. That's it. In order to just sum up what I showed you today, a little bit of how it works. I'm here and super happy for more in-depth questions. Remember that you can share what you want, when you want. You don't have to do like very big steps in order to get started and honestly to see the value that you get from this type of project. Remember that for the time being, it's still experimental, which is, to be honest, what it means, it's not that the platform or the technology itself is not stable or anything like that. We saw in the keynote a lot of applications are actually out there in public with this. Mostly it means that you kind of need to be prepared to explore and be prepared to look at documentation that maybe would be a little bit outdated and so on. Good news is things are happening all the time. You have the community Slack for Kotlin, so use that. It's been super helpful for us. So this is mostly what it means, so that you need to be ready for that a little bit. But as we saw in the keynote and in the content of this conference, this topic becomes more and more popular. Kevin Galligan says it's popular in a good way. I like it when he says that because it means that we all, in a stage where we support one another, we see that a lot of people are very much interested and write for it and write with it. And these are good signs that a lot of good things are gonna happen. It's a really good time, I believe, to jump on the ride and take a part of this journey. Keep sharing your code and with the community. Keep caring for one another. I really want to thank you very much for being here, for your time, for your energy, for your attention. I'm here for questions. I should mention that also if you want to join us to our in our company Advantage for our Kotlin multi-platform project journey and more, then come chat with me. Super happy to chat here or on Twitter. And that's it. Remember to use the application to vote for this session, for other sessions. Have the best KotlinConf ever, and see you around.
all as excited as I am. Okay, I think that's my signal to start. Let me introduce myself very briefly. I'm Liz, hi. I hope you've had a good morning. I want to tell you a little bit about something that's important to me in lieu of introducing myself properly. The most important thing at the moment for me is climate change. I don't do a talk without talking about climate change. I speak at a lot of conferences. This is me sitting in front of a bus in the middle of Banks in London. I have actually joined Extinction Rebellion. I wanted to tell you why. This is the graph that's from the IPCC reports that I saw that made me do that. That bottom graph shows what happens at various temperature levels. So the grey bar is 1.0, that's already happened. There's the 1.5 temperature, you can see everything goes red. At 2, they're trying to keep us to 1.5 to prevent some of the tipping points, some of the feedback cycles that they reckon will happen at 2, at which point it starts running away from us and it becomes increasingly hard for us to do anything about it. We are currently on track for 3.2 by 2050. It's not even on the IPCC's charts. If you want to know more about that, I wrote a blog post on it. It's got some of the sources. It's got some links to stuff that's already happening in the world. It's already really quite bad. It's called Off the Charts. Anything you can do right now to help fight climate crisis is really super important. Please contact your representatives. Email them, let them know that you're worried about this, that they can act and they've got your backing to do so. Obviously, anything you can do as individuals, reusing, recycling. We took the train here from London. It took us 2 days. I'm trying not to fly anymore, so 2 days here and 2 days back. It's worth doing. Thank you for listening. Okay, Kotlin. That's what we're here for. So I wanted to talk a little bit about why I still program on the desktop. I am not a professional developer. I gave that up some years ago. I tend to do agile coaching, leadership stuff these days. But I still program for fun. Back when I used to be a professional developer, I was always desktop-based. And there are still some people who really, really love desktop apps, traders, anything where it's super complicated and you don't want to have to be worrying about scaling and how it performs on different browsers. It just needs to just work. Desktop, you can fix the size of things. You can, it's got a lot more simplicity to it. The other reason I really, really love desktop is because when I'm developing in JavaFX, it is one language, one tool, it's just there. The learning curve for me is so, so small. I don't have to worry about how to deploy to an Android phone, how to get something working on the web. And I've been using this as a tool for teaching people as they come into software. So I've been using desktop as a way of helping people learn to code. And it's really, really easy for them, really satisfying to see something coming up on the screen. But it's still one language, so the learning curve's a lot smaller. For me, since I'm doing this in my spare time, I'm not doing this professionally, I've found I've come back to the place where I have the same kind of constraints as people who are new to the industry. So this is one of the reasons I really like desktop. I am going to be doing this super, super fast today. If you want to follow along, all the code that I'm going to be showing you is available on my GitHub. It's called Hellbound. It is a Tetris game where we drop things into a burning pit. Right? That's why it's called Hellbound. There's a little bit of history to this game. I am best known for my involvement in the BDD community, behavior-driven development. Back when we wrote JBehave 1, which was the first BDD tool, we needed something that actually exercised JBehave and showed how JBehave worked. And the first iteration of Hellbound was written in Java, I think it was Java 1.3, so it's before generics were even available. It was written in Swing, and we used it to drive JBehave and to drive the development of JBehave. So I'm super, super happy to be coming back to this with JavaFX and TornadoFX today. Let me show you the app. Here it is. This is the first iteration of it. So it's literally just an app. It's got this main view. We started up here, right? It's got this lovely main view here. If I have a look at the main view, it's just got an Xbox in it. So if I go back, hold down, and I just run this, and you'll have to excuse me, I'm not a professional dev, which means I'm running on Windows, not a Mac, but there it is. Okay, so it's a box. It's not got a default size. There's nothing else interesting about it. Now, ordinarily, if I was programming using JavaFX, I would have to declare this thing at the top, and then in my init, I would have to do things like maybe I want a border pane inside something, so I'd have to declare a border pane equals border pane. Oh, this is boring. And then we'd have to kind of add the border pane. Okay, this is just tedious. I don't want to have to do this. This is JavaFX, right? TornadoFX does something a little bit magical. It takes away a ton of the boilerplate code, and it makes it super, super fast to get things up and running. So I can just do this. Now I've got an HBox, and we can import that from Tornado, and I can add a border pane if I want to. And I can do, so let's say I want to put a button on the left-hand side. I can do left, I can do button, and we can import those. Oh, not that. Import. Thank you, TornadoFX. Not that either. That's a style sheet. There we go. Okay. And now I can put something in here. So if we were doing JavaFX, we would have to on action equals, and then we have some event listener. I don't even remember what that looks like, so I'm just going to make an object that extends an event listener. Okay, this is already again, it's going to be tedious for you to watch this. We don't actually need to do that with Tornado because it's got action. It's got sensible stuff for just about everything. So you can literally just throw the action in here. It's got some support for dialogues as well, so I'm just going to make a little error box that goes, and now when we play this, we should see, because I've put something in here, the box is super, super small, but if I click the button, it pops up an error saying, right? It's that easy to get something up and running on the screen, and there's not very much code in this at all. Okay. So I said we were going to write a Tetris game, so let's move it on a little bit. Hold on, I've got a command that I can use for this. P2, git checkout. Sorry, my hands are shaking. I am so super nervous right now. If anyone tells you, you know, how do I get over nerves when I'm presenting? You don't, you just do it anyway. Okay, P2. Right, so now we've got a little bit more going on. Let me show you what that looks like. One of the problems with having all these lovely integrated games and everything else is you can't manipulate them, right? If I've not declared the HBox, I can't get hold of it very easily. So I wanted to show you how I manipulate stuff. So now we've got a button, we click it, it goes to a next tab. I actually moved to a card layout later, which is much more sensible. But you can see it's got some stuff on the screen. I'm literally just saying, I can display stuff on the screen. This is pretty typical for how I get things working. I just want to know how do I show that I've got something working, and I'll do random things in it just to show that. But here's how you do it. You declare this thing, and this single assign means it's kind of like lazy. You assign it once, and then it's done. There's a lot of dependency injection stuff available to you in Tornado, and I'll show you a little bit more of that later. You can see the action here just selects the game tab, and we've just assigned the game tab pane and then the game tab using this, and that allows us to manipulate things. That's actually a really big smell in Tornado. Every time you need to grab hold of a component like that, it's because you're not binding it to a view model. And I want to talk about view models and show you view models a little bit. I never quite cleared up all the code, but we did get some view models. At the moment, the only place where the view model exists is down here in this grid view model. So if I go to my game view, if I go to my, I think it's still in the main view, in fact. You can see down here, I've bound, it says bind children here. So I've got a group. A group is literally just a collection of things. And then I've bound the children, which are these squares, and it's giving me a rectangle and picking up the color from the binding. Okay, so when this binding changes, the screen will change as well. I'm not doing this at the moment, I'm just literally showing it. But this observable list, that binding means the front view is observing the list. So you're probably used to MVC. Always have slides as backup when you're doing live coding. This is MVC. You're all used to this, right? You've got a controller. It's got some models. It passes the models to the view. The view reacts to it, and they're probably talking to each other a bit. With a view model, what we're doing is we're wrapping the model inside something that is the presentation that the view requires. And we can bind things to that, like buttons being enabled, disabled, things being visible on the screen. And it means that we're not trying to put stuff like that in the model, and we're not trying to put that logic in the view. It's got its own place that it belongs in. So that binding thing is really key in Tornado. So every time you're manipulating things directly, you could use a view model instead. Like I said, I never quite got round to clearing up everything, but you can see there's some binding going on there. Okay, what else did I want to show you? Right, let's move it on a little bit. Right, so we're now on P3. Okay, let's play the game. What's happening now? So we've got a new game. We've got, okay, so there's nothing visibly different about it, but something is happening behind the scenes that's really interesting, and it's up here. So we've got this events class coming in through dependency injection. I did that mostly just to show you the dependency injection. I was talking to Nat Price yesterday. He said, you don't need to use dependency injection with Kotlin. It's simple enough. You could actually put everything through the constructor. And that's true. I wanted to show you just how this works. So if I go to the Hellbound class now, you can see we've overridden the start, and we've added this DI container and overridden some stuff in that. And if I actually look, we've injected this injector module. So this is one of my classes. And we've just got an events class in there. So when I first did this in Swing, I did it the same way. You have a queue, you have some events that go into the queue, some events that go out of the queue, and some stuff that subscribes to the events. And it's a really, really nice way of keeping that thing between them completely separate. So now instead of having a controller that talks to a view model that talks to a view back and forth, all we're doing is we're sending everything through this events bus. Okay? This means that the view is never, ever going to make any decisions about what happens at all. So what I do is I have requests that come in from the view. The view says, hey, a player did something. Here's a request. And the back end says, you know, OK, I see your request. Here's what's changed, and notifies the view when things work and things need to change. That's really, really simply done here because we've only got one thing that's happening, which is when we click the button, it goes through to this game starter that's subscribed to the events. When the game starter sees, hey, can you start the game? It goes, yes, start the game. Really, really simple, but it's just to illustrate how this works. Okay, little gotcha. If you go here, you will see, in fact, it's in the ejector module, you will see this here, this value here. It's not used. Do not delete your unused values. If you do, the garbage collector comes around. It goes, oh, well, you're not using this anywhere. And because the events bus is not persistent, you will find that the entire engine for your game gets garbage collected. And it will happen slowly enough that your automated tests will not pick it up, but you will be playing and suddenly everything will stop. Okay, so there's a gotcha. That took me a couple of hours to work out. All right. So let's move it on a little bit more. I said I was going to go quickly. Okay. All right. So now let's have a look at what's going on when we play the game. So here's a game. We're going to do this. And, oh, there's some shapes on the screen. Look, it's starting to look like a Tetris game now. And we can actually move this shape. We can move it off the boundaries, never mind. We've started, we've got something on the screen. It can go all the way down. When it gets to the bottom, nothing happens. It just goes off the bottom. There's no up in Tetris. But so we can at least move some stuff. We're doing some things, which means we have some behavior. We've got some behavior that's actually interesting. So for the first time now, we've got some scenarios. So let's have a look at these. Okay, so you can see my scenarios here. They say things like the grid should start empty. I absolutely love that you can make functions, strings in Kotlin. I only ever use it for tests, for the scenarios, and I'll show you the unit tests in a moment. You can also see that I've got given, when, then in comments. Has anybody not come across BDD here before? You all know BDD, you all know given, when, then, right? So this is how I start. I'm not using any frameworks. I'm not using any tools. It's very procedural right now. I've just got started. So I've got, it's a bit messy. That's fine. It's got all the glue that makes it look pretty here. But you can see it's enough, right? And this is documentation. The way I think of BDD is it's documentation for how the system works, how the system behaves, not just tests. When I want to know how something behaves, when I've come back to my code after a long time because I'm programming my spare time, this is how I find out what was I doing, how do I understand the code. Okay, so you can see we've got some scenarios running. It's running just fine. I can run these. Let's run them all. Run all the scenarios. This is automated. I'm using an automation framework that I wrote myself called Stirry. I have a very bad habit of reinventing the wheel when I don't understand something. So I tend to write automation frameworks when they don't exist. So you could just see it just flashed up on the screen there, and it is actually running. The grid starts empty, pressing a key starts the game, and then you can rotate and move the shapes around. Okay, there's a problem with this. I want to show you what happened the first time I did this, and it has to do with this little thing here. So I'm just going to remove that, and we're going to do it again, and you'll see what happens. It failed, okay? It failed, and the reason it failed, if you come down here and you look down here, it's expecting empty grid. I've got a string representation of the grid, but it's had a T shape at the top, so that's the grid starts empty. And it doesn't start empty. It's picked up a T shape. It's done it super fast, so I'm not going to show you. The reason it's done that is because that scenario started in the same JVM as the previous scenario. So it's picked up all the stuff that was a singleton, all the stuff that I dependency injected from the previous instance. If I want to stop that happening, I have to scope my dependency injection. That's why that's there. There's a whole ton of stuff around scope. So Edwin Sayce, who wrote Tornado, he's got some beautiful, beautiful manuals that explain everything that I'm telling you today in much more detail and much more beautifully than I can. Scopes are really, really useful for testing. So just remember when you're testing, if you get this interaction, it's probably because you haven't introduced the right scope. Okay, let's move it on. What's next? Scopes, scenarios. We've looked at scenarios. Oh, unit tests. I didn't show you the unit tests. So we do actually have, I think there's a controller test in here. So the difference between my scenarios end-to-end and my unit tests is my scenarios are looking at the whole system. The controller test is only looking at the one class. So I'm actually mocking out the game here using Mockito, one of my favorite mocking frameworks. I've given to understand that there's some really nice Kotlin-based mocking frameworks, and you can do all kinds of fun stuff with functions. But I don't get to pair. If anyone wants to come and make this look better with me afterwards, you're welcome to do so. I'm just using Mockito to mock out the game. So this is just, it's got the same structure of given, when, then, though. So the idea is given is a context in which your system starts or what your class is set up to have, and then something happens. Either you use the class or something happens with the system, and then you get some result at the end. And I use the same pattern of BDD for unit tests as I do for those end-to-end scenarios. So I see this given, when, then everywhere. You'll see later that system level, I tend to refactor out that given, when, then into something a little bit more readable, a little bit more reusable. The comments, just leaving the comments in here has been enough. I've never found the need for any of the spec-based frameworks. I just really like leaving them in the comments. It's very easy. And again, one less tool that newcomers need to pick up. So there you go. That's the unit test running. I'll just run them so you can see they do run. There you go. And they all start with word should. So this class should do this stuff. Okay, what's next? I've got a presentation somewhere. There we are. Okay, so that's going to be fun. Where's my thing? Please bear with me while I just get these bits. There we go. Okay, so we've moved it on a little bit more. So let's now look at the game again. Just going to run this. Something interesting is happening, and it's super, super exciting. When I start the game, and there's a shape. Oh, it broke! Everything went horribly wrong. Why is everything going horribly wrong? Let's go have a look. I know what, my automated scenarios, they should be able to tell me what's wrong. If I've got a bug, I should be able to go to my can, play the game, and I should be able to just run this, and it will tell me what's going wrong with the game, right? And this is why you should never, ever rely on your automated tests. Always, always check it manually, okay? The tests here are working absolutely just fine. So let's find out again what's going wrong with this. Okay, let's run this again. And this time I'm just going to quickly look at the stat trace and we'll be able to see what went wrong. Okay, so starting the game, and okay, there's the error. So let's quickly look at that. And it says, not on the FX application thread. So what's happening is, when I'm in my automated thing, Stirry, this little automation framework I wrote, it's actually running these events on the heartbeat notification on the FX thread. So there's two threads, there's the main thread and there's the JavaFX thread. JavaFX gets really, really upset if you try to make events happen, if you try to make things on the GUI happen, do not happen in the FX thread. And that's what's going on. So there's a couple of ways of dealing with this. One is, if I look in the injector module again, one is that you can declare the coroutine scope. So I'm using coroutines. I'll show you that in a sec as well. I'm using coroutines for the heartbeat. I can tell you that when I did this in Swing and Java the first time, there was waits, there was locks, there was, all the thread model stuff. The class was about this long that made the heartbeat work. I'm using coroutines, and it's so, so beautiful. This is it. That's everything that does the heartbeat, and it accelerates over time. Okay, this whole game took me about a fifth of the time to write in Kotlin with Tornado than it did when I did it in Swing. And I know I've got some learning already from that, but it's still so super fast in comparison. So here's the heartbeat notification. This is where it's pushing the events through. There's a couple of things that we can do to fix it. One is to introduce a coroutine scope, inject it, and do it here. And the other one is to use the bridge. And I can put dispatch main in there. Now, the dispatch main does not come, dispatchers, main. There we go. That doesn't come from TornadoFX or JavaFX or anything else. That's in the Kotlin's coroutine, but it doesn't work unless you've got the bridge in your class path. So it's kind of magic. In retrospect, I think I would prefer that first way because it needs that in its class path, that JavaFX there. If it doesn't have that, it fails. And then you're left with magic, which doesn't really fit with me and Kotlin's whole type system. So in retrospect, I would probably use the other way and do it explicitly. Okay, but we've got something working now, and now when I run Hellbound, so I can't remember where we were, so I'm just going to run like that. Now when I run it, it should work, and you can see the shape drops over time. Okay, so that's all that's happening now. Brilliant. Coroutines, we love them. Okay, and the JavaFX bridge. These slides will be available, by the way. All right, let's move it on. Where are we? P6. Force it. There we go. All right. So let's play it again. Something really pretty happens now. So now we've moved the game on a little bit. We have an actual game, and it's pretty. It's got some stuff so you can see where the columns are because I kept getting fed up of dropping the shapes in the wrong place while I was trying this out. And I'm not brilliant at Tetris, but I said I wasn't brilliant at Tetris. Look at that gap there already. Hopefully I get something, there we go. So we can make a line and the game is actually working. There's a nice little score mounting up on there. And when I click it, it's going to go to a nice little overlay screen that will tell me the game is over. And it will say, game over, man, game over, in tiny, tiny writing. Okay, so we've now got this pretty game going. Let me show you how that's working. It's in the game view. So the game view is still bound to this grid model. It's still picking up the color from the grid model. But now it's got these radial fills that are giving those squares their lovely shading. Okay, and you can see the isEmpty one, those little dots are caused by making a circle that's a bit too big, and then it just leaves those little dots behind. And the all the other shapes which aren't empty, they've got these lovely radial patterns to them. That means that our grid view is now a complete mess. And if we were to try and do that for everything, we would have presentation logic absolutely everywhere. Traditionally, with JavaFX, you would get rid of that by using a style sheet. Style sheets are CSS type. They look a lot like CSS. CSS is just strings. If you get the strings wrong, then it either doesn't display or it gives you some kind of error. And you don't find that out until you run them, which is not like Kotlin at all. We have something else we can do. And this is one of my favorite things about Tornado. Okay, so now we're using these styles. TornadoFX has type-safe style sheets. So I've wired this into the main app. You can see here. That's how you wire it in, is that styles class. It was there, but it was just empty before. And now I've got this CSS class. You can also do things by CSS elements. So if I wanted to, there's an IDs, there's all kinds of ways. I just declare some style that I want by CSS. Element, ID, properties, there's all kinds of things that you can use to do the selection of your elements. And you'll see if you want to check out the code, you'll see I've got some stuff around that as well later. I'm not going to do it because I'll run out of time. But here's the real magic. Because it's type safe, because it's declarative, I can actually put logic in there. I can actually say things like, if it's like this, do it like this. You know, I've got a to rounded rectangle, I can call functions in there. You can't do that. You just can't do that with your ordinary style sheets. So this has been totally magic for me. Okay, let's move it on again. Oh, sorry. There it is. So this is where it starts getting really fun. Oh, sorry. Touching the type pad. Okay. All right, so now we've got a much richer style sheet. And when I actually go to Hellbound and I play, you can see it's going to be so beautiful. Right? There we go. So we've now got some much nicer style sheets. I am not a graphic designer. I am a cyber goth. It's black with shiny things on. Don't get me to design things because I'm not a good designer. But I can show you. We've made it even a bit prettier, etc., etc. When we actually lose the game now, something really exciting happens, and I can show you that too. This isn't the biggest change. Okay, so now when we've got a high score, I need to make that box bigger as well. Now we've got the high score. It's bound again with the grid view model, with the view model. So if I go to, I think it's the welcome screen, welcome view again. Everything's still happening with those requests and notifications. So I got a notification that a high score was achieved. Somebody's achieved a high score. This prompts the front end to pop up the dialog box, and it records with the high score, it says, okay, I've recorded the high score. And then the front end says, okay, well, now your high scores have changed. And the high score is bound to this simple string property. It still means it may look a little bit complex, but it's been so easy to change this when I got it wrong. It's been so easy to work out, should I have a dialog box? Should I do it from the welcome screen? Just because everything is separated. So there's multiple different ways I can look at things. It's a really nice tool for prototyping stuff as well. So again, we're bound to this simple string property. And when I declare my label, it's literally just bind highscores.text. There's the binding right there. And that changes when the string changes. And it's completely independent. So I can move those to different views. I could have something completely separated working on the event bus to pop up that dialog, and it would just happen. Okay. The really exciting thing, though, is what's happened to the scenarios. So I'm just going to escape presentation mode a moment so I can just show you these. So I can grab all the scenarios. So now if I run all the tests, there are very much more of them to start with. I also don't know why this is so tiny when I run it through the scenarios. This is a very, very high DPI gaming laptop because I'm a gamer. Something around this is making those super small. I'm not that worried because I'm not trying to run it with this. As long as it's testing, it's fine. Okay. I know from having done this before that those are timing issues. If I do it again, it will work just fine. I need to resolve the timing issues. So those failures are timing issues, but whatever. Okay, presentation. Into presentation mode. Right, there we go. Okay. In fact, it might well be because I had the class up. It might just be because I had that up. So now we've got these really, really readable steps. It says, given a game that's new, when the player presses any key, then the grid should look like, and I've got a string representation of the grid. Okay. All I've done is take those comments that said things like, given a game that is new, and I've looked at what the root is. So in this case, it's the game. There's some stuff around starting the game, playing the game, and then there's some stuff around the grid. There's some stuff around what the player does. I've extracted those into roots, and I've written a whole blog post on how I do this. This is where my real strength is, so if you do want to ask me questions, please make them about BDD rather than Kotlin. You'll get much more interesting answers. So this is the scenario class, and I've tried to keep this really, really clean. Each of those roots goes to an object that has all the nitty-gritty to do with those, and they're page objects. The really cool thing is hardly anybody that I speak to who does BDD and who uses the BDD tools, Cucumber, JBehave, hardly any of them are actually showing those scenarios to business people. There aren't people reading those. And those introduce another level of indirection. They're hard to maintain. You can't refactor them easily. Even my non-technical PO is capable of reading things like that, right? And the abstracting those out means I've now got some nice reusable steps. It's really easy when I want to add a new scenario to just add them. So I've started taking that duplication out. My product owner can read this, right? And as you can see, when something goes wrong, I can just dive into the steps to see what goes wrong. People have said to me, they've said, you know, but you want to be able to read very easily why things go wrong. They're not tests. If you're doing this in real life, they should hardly ever go wrong at all. Them going wrong is usually because you've got some timing things that you need to sort out, which might mean a genuine race condition. We've encountered that a couple of times. It's going wrong because your design is not great and you've introduced regression bugs, and that's a sign to clean up your design. I prefer to think of these as examples of what the code should do. So I'm just going to run this again. I do think these failed because I had the thing up. So let me just run these again. All hellbound scenarios. There we go. I had a game up already. So I'm just going to run them again, just so you see them go green. There we go. Now it's working. Okay. I'm a huge, huge fan of automated scenarios. I'm an even bigger fan of unit tests. Because I was getting this ready in time for this deadline, I don't have as many unit tests as I like. I need to go back and do some refactoring and put those unit tests in. Please do pay attention to your test pyramids. These are just examples of how the game behaves. They're not rigorous regression tests, and I don't think anyone should use them that way. And that's it. It's game over. So does anybody have any questions? Anybody want to, was there anything you were hoping to see from this that I haven't shown you? In which case, I'm just going to tell you, there's one other thing on my GitHub. It's called Keogh, K-G-O-L, Kotlin Game of Life. If anybody wants to play with, it's JavaFX rather than TornadoFX, I'm going to convert it. But if anybody does want to teach Kotlin to other people, it's got the front end but not the back end, so you can actually put the engine for the game of life in really, really easily. I've used this for teaching people how to code, and if you're going to do it, I think it's a really nice way to do it. So it shows things on the front end as you get the rules working. If you want to come and geek out with me and help me make this game better and show me all the things I'm getting wrong with Kotlin, please find me later. Thank you very much.
Where's the guy?
Oh, he's gonna do.
Do we start? Hi, everyone. I'm Katie Levy.
And I'm Shelby Cohen.
And we're both here from Intuit from San Diego, California. We're really excited to be here today.
And I'm really excited because last time we spoke at a conference, Katie lost her voice the morning of the conference. So today we both have our voices and we're excited to get started.
So I work on TurboTax, and before I was working on the mobile app for TurboTax on the Android app. People are really surprised you can file your taxes on your phone. And then more recently, I switched over to more of the back-end services for TurboTax, working on Spring Boot applications.
And I'm in the developer productivity organization at Intuit. So I lead cross-division engineering efforts to provide seamless development for all of our products at Intuit. So Katie's product that she works on, TurboTax, and also Mint and QuickBooks.
So today's presentation will be successful if you take away some key techniques to influence change, and all through the lens of how we influence change at a 9,000 employee company that's over 30 years old by introducing Kotlin and functional programming. So a little bit more about Intuit. It's a 9,000 employee company with 19 locations in over 9 countries, and it has over $6 billion of revenue per year with over 50 million customers per year.
So most of you know JetBrains open sourced Kotlin in 2012, and the first stable release was in 2016. Our journey started in 2017 when we started working full-time at Intuit. We attended a functional programming meetup where we learned about functional programming in industry for the first time. In 2018, once we heard about the language, but we had never used it, we started playing around with it outside of work and quickly saw the benefits and how much we loved the language. After that, we wanted to use it in our everyday development at work, so we tried to get our teams to use it and introduce it to Intuit. Now, 2019, Intuit is using Kotlin in a lot of our apps, in our Android apps, our server-side Spring Boot apps, AWS Lambdas, and more. So what is functional programming? It's when you treat your code like mathematical equations. So with the same input, you have the same output with no side effects. It's when you compose smaller functions into larger functions. It's when you avoid shared state and mutable data. And it's really good for multi-threaded applications. We found that functional programming was really helpful to improve the quality of our apps in general, and Kotlin was a great way to teach functional programming. It can be really scary and daunting at first, and people have this idea of what functional programming is, but today we're gonna break it down for you and show you how we taught people at our company what it was.
So these are the 8 key techniques that we're going to walk you through in this presentation and how we specifically use it on our teams and then got larger to the whole company. So the first step is you really have to find your passion. You have to find something you're so excited about, you could talk about all day, it just makes you so energized. And for us, that was Kotlin. We found that Kotlin solved all the main pitfalls that Java had. It was so easy to write, it was so fun to write, it was easy to read, it was so concise, it was safe with the null safety, it's interoperable with Java, and then it's also tool-friendly with all the tools we're already using today.
So once you find something you're passionate about, you're gonna wanna share that passion with other people and socialize the idea. What was my experience like? I mentioned I was on a developer productivity team. So we build internal applications, and this is a really great place to try out new technologies. My experience was actually really easy to add it to our Java Spring Boot app. I wrote a feature that I was already going to develop that sprint in Java in Kotlin instead to prove to my team why it was a good idea to use it. After I did that, I wanted to bring the whole team along and get everyone coding in Kotlin feeling comfortable. So we converted all of our Java data classes to Kotlin data classes.
Throughout the way, any problems we ran into, we created learning resources just for our team so we could document any issues we ran into, and it also empowered every team member to feel like they were an expert in a specific part of the language.
That's crazy because my experience was totally different, but I, at the time, was on the Android team. You would think introducing Kotlin to the Android team would be so easy, but we had some engineers on the team who had been coding in Java for over 30 years, were so comfortable with the language, they knew what they were doing, they kind of were like, why do we need to add this new language in? Why do we need to change our whole style of programming? And so I really had to break it down to them in different presentations on like, these are the key features that I love, and this is why I think it's beneficial for you to start learning the language and use it in our application. We would also do some different group coding where we would do live coding on refactoring Java code into Kotlin or writing new features and classes in Kotlin. It really taught everyone together and got us to discuss and socialize the features and why we like them. Even at that point, there was still some hesitancy, some people wondering why do we need to use this language, and discomfort with the whole foundation of the language. And so we had to do a group training course to really get everyone on the same page of this is how you use Kotlin, this is how you use the features, this is the benefits of it, and that really got us going in the right direction.
Now, there's a lot that Kotlin has added on top of Java, so we had a lot of things to socialize. We're not going to go over all of them today, but some of the bolded ones are different parts of Kotlin that we started out with. One of the first features we fell in love with that we know most of you here probably also fell in love with was null safety.
So who has had a null pointer exception? Yeah, pretty much everyone. It's the billion-dollar mistake. It's cost the industry billions of dollars. And anytime we had a null pointer exception in Android apps, we'd get a crash. In this survey of over 1,000 applications, it was the most common exception. So this was a key data point that we really were socializing as much as we could, saying that Kotlin brings null safety to the table.
We also compared Java null checks with Kotlin null checks. So you'll see on the left a typical Java nested if statements with a lot of null checks. And then if something ends up being null, we just return null. That doesn't tell us anything, but if we were going to convert that same code to Kotlin, it looks a lot more fluent with the chaining and the safety operator.
So at this point, we've socialized the idea, kind of talked about what we like about the language, and then we really have to sit down and create a proof of concept to really show the engineers and have them feel the benefits of Kotlin that really make you fall in love with the language.
So we've mentioned Intuit is a big company, and when we want to make technical decisions, they usually come from our architects. So when they do that, they need to get buy-in from the engineers. They also need to consider things like a common tech stack and industry trends, because we need to find the balance of exploring new technology and then considering past decisions that we've made. However, when we introduced Kotlin, we were the first ones in our company who really wanted to use it, and we needed to convince those architects that this was a decision that they should make. When we were doing this in the beginning, we wanted to get feedback and kind of show off some of the Kotlin we had just started writing. So we set up a meeting with one of the engineers that was more senior to us who had experience with Kotlin, and we sat down and we wanted to show off kind of everything we've been working on, hoping that we can improve it. He ended up inviting a lot of the Java leaders at our company so they could kind of get exposed to what Kotlin was and see what we were working on. They had a lot of questions, and in that moment, we realized we were in our small bubbles of our team and what we were specifically working on, and we needed to account for the huge ecosystem that Intuit has. It's not just our specific team, and it's not just TurboTax. It's all of our products, and we need to make sure we're making a decision that's right for everyone. That transitioned us into forming a detailed proof of concept so we could answer any questions they had and be prepared.
So one of the key pieces we put in the proof of concept was data classes. This just right off the bat shows you how concise Kotlin is. You have a Java data class that you write, getters and setters. If you have a typo and copy and paste and you forget to change one of the names, you're gonna have a bug. Kotlin data cluster is just concise. You're less error prone. It just really drives the point of why Kotlin is so great in terms of conciseness. And that was a great proof of concept for engineers and the architects to look at. On top of that, we also want to have proof of concept for functional programming. This is like, why do we want to use functional programming in our applications and what is the benefit that it's bringing to us? So Kotlin has Lambda support where functions are first-class citizens of the language. Java 8 has it as well, but Kotlin goes on top of that by having functions on the standard library collection. So you have the functions built in already for things like map, filter, fold, flat map, which really enables people to learn functional programming and use it really easily when they're writing Kotlin.
We started by using map, and we showed the comparison of Java map to Kotlin map. So you'll notice in Java, we need .stream, and then at the end, we need .collect. Whereas in Kotlin, you just simply do .map on the collection, and you can use the keyword it to make it even more concise. Similarly, filter is doing the same thing. You don't need that .stream or .collect, and you can use that it keyword again. When we were introducing this stuff, we didn't want to say, okay, everyone use every Kotlin feature you could ever imagine. We wanted to start slow and say map and filter instead of for loops with if statements.
So at this point, we have a proof of concept, some of the big features that we love that really drive the point of why Kotlin and functional programming is so great. Then we have to sit down and create a plan. So for my team, we had some hesitancy, so we had to go around and I had everyone say on a scale of 1 to 10, how comfortable are you with Kotlin? And I was expecting everyone to say around 4 or 5, and it surprised me when everyone said around 1 or 2. And it really showed that people felt low confidence, they didn't feel comfortable, they needed more practice, they needed more time. They've been coding in Java for 30 years or so, and they needed to build up their expertise more. So that's when we sat down and we said we need this training program to really prioritize our time. We already had all these other features we need to get done, so it really blocked out time on everyone's schedule to sit down and do an online training course together and learn the different key features of the language together. Then we sat down and we said, what are the goals that we want to accomplish with Kotlin? We first want to start with test classes. Those are pretty easy to convert with low risk, so we're not affecting any of our prod customers. So we started changing test classes into Kotlin, and then it built up some of the confidence. The next step was doing data classes. That's like an easy way to cut down Java lines of code, and you can add in a data class. Then the next step, which was the bigger step, was new features. We said all new features we want to write in Kotlin. And this made sure that we were all on the same page of the timeline we wanted to accomplish different steps and the milestones we wanted to reach. Then after that, we wanted to create a measurement for our impact. We wanted to see how is Kotlin really impacting our team and bringing us benefit. So one data point for that was when the features I wrote cut down the number of crashes by 60% in the app. That really showed this is creating higher quality applications, and this style of programming in Kotlin is really helping our production live customers. On top of that, it was also helping our developer productivity. It was allowing us to write the features faster for the developers to write, and then also less lines of code. So even at that point, we had been on the same page. Everyone was clear on the goals. We still can run into issues. I had one of the engineers on the team who was actually the tech lead. He'd been writing Java for years and years, and I was really excited when he decided to write his new feature in Kotlin. And he submitted a PR and had it ready. I reviewed it, and it looked pretty good, but I wanted a few more people to review it just to make sure everything was great. I sent it to Shelby, a few other people in the company that knew Kotlin, and had them review it. We had to get it merged in the next morning because we had to cut a release for the app. So we were in a bit of a time crunch. And so all these other engineers reviewed the code, added their comments, and the next morning the engineer comes in, looks at his PR, and was so overwhelmed. He saw these comments and he broke down and he said, I'm just gonna rewrite it all in Java. I'm not gonna do this Kotlin thing. I really had to sit down with him and say, no, it's okay. Like, you did a good job writing in Kotlin. We need to just change a few little things. They're nothing big. We want to teach you the language by writing these comments in. But it was a big learning lesson for, him to learn new features, but also for us to take a step back and put ourselves in the shoes of when we were first learning the language and our expertise at that time and the journey it took to learn the features and slowly get there. So we really have to sit back and adapt to the different people on the team. We need to make sure we're helping them along the journey and bringing them along and not leaving them in the dust. So we really set up a feedback loop of understanding what is the comfort level on the team, what is everyone feeling like with the writing new features in Kotlin and making sure all of the issues were addressed.
So even with a plan and with defining what success looks like, we still need something to persuade people even more. And what's the best way to persuade an engineer? Data. So we use things like this with quotes from the Kotlin website that has a rough estimate that there's a 40% cut in the number of lines of code when you're converting code to Kotlin. And more concise code takes less time to write and, more importantly, less time to read. And so that improves your productivity and lets you get things done faster.
So one of the key data points is the boilerplate code and how much Kotlin reduces the boilerplate code in the number of lines of code. So here we have different features of the language, like type inference. You don't have to explicitly say the type of the variable. You have single expression functions, so you don't have to need the return body. You just have it look more like a mathematical equation. And then also string interpolation when you're writing out strings. So here is a Java function of getting the greatest cities. You have an array list with San Diego, since that's where we both live, Boston, because Shelby's from Boston, Seattle, because that's where I'm from. And then you're iterating through the array list and getting back the Boston, which is where Shelby's from, and then returning back that list. So to prove the point on how many lines of code this really is, we want to have Shelby write this out in Kotlin in a non-functional way. And we need some help from the audience on how many seconds you think it's going to take her to write this. Can I get some guesses?
Can we share the other screen up there? Can we share the other desktop? No? Okay.
No.
All right, so I'm going to do it, and Katie's going to time me, and you're going to have to trust me that this is what I'm doing. So ready?
Can we get some guesses of how many seconds?
15?
15, 30,
20?
20? Okay.
0.
Magic. Okay, I need everyone's help to say 1, 2, 3, go with me, and she's gonna start typing, and I'm gonna start timing. Ready? 1, 2, 3, go.
Done. So you were right.
2 seconds.
The reason why it was so fast is because I took advantage of my tools in IntelliJ. So we wanted to show you guys you shouldn't be doing everything manually. If you copy Java code into a Kotlin file, it'll automatically convert it for you. Or you can convert it by converting the whole file from Java to Kotlin. We use this as a tool when a lot of people on our team were learning and they were familiar with Java. So what they would do is just convert the whole file at first to look at the differences and then optimize later.
So also on top of that, we can cut the lines of code with writing it in a more functional way. So bear with us when we try to get the screen up there. But actually works. So we found it really helpful when we were teaching everyone also on our teams to do live coding with the team, and we can use the IDE and do all the cool tips and tricks and show them. It's a good way to sort of teach people the language, but also teach people the toolings in the IDE. So a lot of people don't know things like you can do option enter, you can do the whole copy and paste like what Shelby just did, which is really helpful. So this is what she ended up copying, pasting, and turning it into Kotlin in 2 seconds. That was a record time. So now we need a little more help from the audience. How many lines of code do you think it will take her to write this in a functional way in Kotlin? Can I get some
4.
guesses?
1.
1. Ambitious.
All right, let's try it out.
Let's see what she can come up with. All right, so she's starting at the function, returning a list of strings, and creating a list of the different cities. It's an immutable list. And then, after she has them all written, she's just going to call filter on it. And using the it keyword, she can check if the item in the list is equal to Boston.
So I think we can make this even better. It's 3 lines, but if I take advantage of my tools again and hover over the return keyword and click option enter, it'll give me this option to convert to an expression body. If I click enter, it will highlight the return type, indicating that I can actually remove it and take advantage of type inference. So now we've got it down to 1 line. Good guesses.
Yeah, nice. So this really proves the data point that it's cutting down so many lines of code. It is so concise. It can help you with not only writing the code, but reading it. And then on top of that, we have other functions that you can use, like flat map. So we went over map and filter, but at this point, the team was starting to get a little bit more comfortable with the functional programming style. They're realizing whenever they have a for loop, they should just use map instead. Then we started introducing flat map, and that was like a little bit more for the team to take in, but you have a list of lists, and then we're iterating over the list and adding 5 to it. And on the left, you can see the Java code. You still need to do the collection at the end, but for Kotlin, it's a lot more concise. You have the flat map over the list of lists, and we have the inline operator of the plus to add 5 to the list, which adds 5 to every item in the list, which is awesome.
So all of these companies have Kotlin in production today, and this was another data point that we used to influence into it. Kotlin was also rated the 4th most loved language on the 2019 Stack Overflow survey. So all these things put together just helped influence all of the leaders. So even with sharing all these data and facts, there's still some myths that we need to deconstruct. It's important to break it down for people so you don't have false information spreading around. One way that we deconstructed myths was by writing a technical white paper. So this started out as an internal document for Intuit, and we really went through and explained what problems were we solving that we faced in Java. Through the process, we found it really valuable and got a lot of awesome feedback internally. And so we decided to make an external version of the white paper to help other companies influence to use Kotlin. So if you scan that QR code, you can read a blog post about our journey, and it links to our formal technical white paper.
So one of the myths we deconstructed is Java interoperability. A lot of engineers at Intuit were thinking, oh my gosh, we have to change to Kotlin. We have to refactor our whole application. And that's not the case. So we really had to break down to them, this is how the bytecode is generated. It just becomes Java bytecode. You have the standard library that's added in. You add that to your Gradle file or your Maven file, and then you can run your application with both Kotlin code and Java code. This was really nice for us to explain that you can incrementally add Kotlin into your application. It doesn't have to be a whole migration blocked off period of time where you're not developing new features. You can slowly add it in. We really took on the methodology of leaving some of our Java code that was still good the way it was, and then adding new features in Kotlin to really take advantage of the language. And anytime we need to refactor something, refactoring it into Kotlin.
We also had to make sure that Kotlin was supported with all of our tooling we used for Java. So we went through and put this in the white paper explaining that all of our build tools, all of our testing and code coverage tools, our CI/CD pipeline, and our IDE support was going to be just as good in Kotlin with no work.
Another thing that came up was, what can I use Kotlin for? A lot of people thought it was just for Android applications, and really had to break it down to them that it can be used for anything that runs on the JVM, so server-side applications with Spring Boot. You can use it on Android, you can use it on Kotlin JS, you can use it native, and these are all different IDEs. So this really opened things up to engineers saying that we're not only just doing this for Android applications, but for server-side and other platforms as well.
Now, Kotlin's easy to learn, but we also found it a great tool to teach immutability and functional programming. One of the ways that Kotlin encourages immutability is when expressions. So here's an example that we showed people where we have a function, getNumber, and it returns the type string, and when a param is sent in with a 1, it returns a string 1, 2, a 2, and then if it's not, we don't know. And what's cool about this is if we change any of those branches to a different type, it'll be a compile time error. Also, we're never mutating the return variable.
Another good way to start using functional programming is using immutable variables. So Kotlin has it clearly defined by having the val variable as immutable and then the var variable as mutable. On top of that, with lists, if you want to create a mutable list, you have to explicitly type out mutable list of, whereas immutable list is just list of, encouraging you to use immutable variables more.
So we're encouraging immutability and functional programming, but is that enough? Is our initial problem of what we were facing in Java actually being solved? This is where Arrow came in. On my team, once everyone was comfortable writing and reading Kotlin, we introduced Arrow. And Arrow is a functional companion to Kotlin's standard library. And we found that this continued to solve more and more of our problems. So some abstractions over Kotlin libraries here are option, try, either, IO, functor, applicative, and monad. And these are all very overwhelming and can sound very scary. And so it's important to note that we didn't say use everything in Arrow at once. We introduced it slowly and incrementally, just like we did Kotlin. So Kotlin's mission is to empower users to write pure functional programming apps and libraries built atop higher order abstractions. And this was really what we were trying to do and the problem that we were trying to solve of writing more pure functional programming apps at Intuit. So as I said before, we didn't start with all of them. The first type we started with was either. And this was a really awesome, easy thing for Kotlin developers to grasp because under the hood, it's just a sealed class. So an either is used to hold successful values. And you can define a right and a left. So the right is typically a success and the left is typically an error. So in this case, we have the right as an integer and the left as a string. So if we call either.right with a 5 sent in, the 5 will be wrapped in an either.right. And then if we send in either.left with a string, it will return a left with the string inside. Also, you can use map and flat map on top of either. So when you do that, it's only going to operate on the right side. So it will continue on, and you can chain things, and it will only operate on a successful value.
So let's take a look at how we can use this either type instead of throwing exceptions. These are 3 functions where we have parse. It takes in a string, and it's just parsing it into an integer. If it matches the regex, it will return back the integer. If it doesn't, then it will throw a number format exception. The next function, reciprocal, it will take in an integer. If it's a 0, then it will throw a legal argument exception because you can't take the reciprocal of it. Otherwise, it will take the reciprocal of the value and return back a double. And then we have stringify, which will take in the double and just stringify the double into a string. So let's see how we can change these to use the either type. For that first function, parse, we're going to return back the either type of either number format exception on the left, which is the error case, or an integer, which is the success case. So if the string passed in matches the regex, we'll return either .right of that string to an integer. Otherwise, we'll return back either .left of the number format exception. So that number format exception is wrapped inside of the either type. So we need some help from you guys on what you think will be returned if you pass in not a number to this function. Can we get some guesses from the audience? A left. Yeah, so left of number format exception. So this is what it would look like. It's going to try matching it to the regex. It will see it's not matched and return back the either left number format exception. So what will happen if we pass in a 2? Yeah, either .right of 2. So we're going to make it a little more challenging with some of these other functions that I was talking about earlier. So reciprocal. We're taking the reciprocal, returning back either of a legal argument exception or a double, stringify, returning back a string, and then magic is really putting everything together. Magic's going to return back either of the exception type or of string. So magic is going to parse the string, which will parse it into an integer. Then it's going to call flat map, so it will iterate over the success value. And then it's going to take the reciprocal of that value using the it keyword. And then we're going to map over that to stringify the value. So putting all these different pieces together. So what do you think we'll get if we pass in 0 to magic? Yes, either left of illegal argument exception, because you can't take the reciprocal of 0. Awesome. So what if we pass in a 1? Nice. Yeah, so we have either right of 1. And what if we pass in not a number again, but to the magic function? Yeah, the either left of number format exception. Awesome.
So putting this all together, how we would use this, we can actually, in a when expression, use smart casting to either .left or either .right and define what we want to do in that case. Here, we're also smart casting to the specific types of exceptions and then defining an error message that we want to return. So this is a function that we typically used to see in a lot of our Java services, and there's a lot of improvements we could make here. I'm sure you guys see some of them, but there's a lot of mutation of the integer status. There's some nested if statements. There's a try-catch. Something's throwing an exception. We're not sure just looking at this one function. And it can get really tricky when you're testing and when you're debugging. A way we can improve this using the either type is by defining the success state at the lowest layer of the code. So here we have a when expression, and when the status is 200 or 201, we're going to call that a success, and we're going to wrap the status in an either.right. You can also wrap the response body, a response object, anything you want. But what's important here is that this function returns an either, and at any other place in the code, you're going to know if it's a success or a failure. We can again do that same smart casting and say when the response is either .right, return a specific response message, and then if it's either .left, return a specific error message. Again, these were just 3 of the main things that we found from introducing just one type from Arrow. So imagine all the things we can do as we slowly, incrementally introduce more and more. We want to put the status checks at the lowest layer of the code. We want to handle errors with types rather than exceptions, and we want to avoid mutation.
So at this point, we've deconstructed the myths and told everyone this is really what Kotlin functional programming is about. At this point, we can't stop, we won't stop, we gotta keep going. We'd reach our teams, but we wanted to get bigger and reach the whole company. That's when we started the learning community, where we would meet once a week for an hour during lunch at Intuit with Intuit engineers to talk about some of the key features of the language through presentations, live coding, code reviews, and then also going through Kotlin in Action, the book, to kind of find the best practices for the language. This really helped us build a community of engineers that were passionate about not only learning Kotlin, but also teaching Kotlin and using it on their teams.
Something we did in the learning community was open contribution and open source. So that's when someone from another team would contribute to my team's project, even though that's not normally what they work on. I don't normally work with them, and they also don't normally work on that tech stack. It's a great opportunity for people to learn this way through PR reviews, and it gets a lot of work done because it's work that my team has already defined by tagging help wanted or good first issue, just like you see in a lot of open source projects. It's just within Intuit. Overall, this has helped us empower different people on other teams to start using Kotlin, and then they can help us introduce Kotlin back to their teams.
So once we reached Intuit, we wanted to get even bigger and connect with the larger community. That's when we started reaching out on Twitter and Slack, finding people that were doing really cool things in the industry, people that were providing learning resources that we would share back with the learning community, or sharing out things that we had worked on. And one of those things was an open source library that I did for Android UI. It's called Truffle Shuffle. It was written completely in Kotlin and with functional programming, and it was a way to show off some things that we were working on internally at Intuit, but then open source it into the greater community of Kotlin.
Also, attending and submitting to conferences has been a great experience for us. Last year, I actually volunteered here at KotlinConf, and I got to meet and see a lot of amazing speakers, which inspired us to come here the next year and speak to you all. We also got to meet a lot of people by going to conferences. Last year, I met Hadi from JetBrains and started talking to him about what I was working on, and he invited me to be a guest on his Talking Kotlin podcast. And so just putting yourself out there and going to events and networking with this community is how we kind of fell in love with the language even more and helped grow inside the company too. So we have a few QR codes for you all to look at. We were recently featured in Forbes talking about how to influence a tech company. So if you want to read more about our journey there, we'd love to get your feedback on that. We also have a Intuit Kotlin webinar with some other awesome Intuit engineers, and they share more about other places in Intuit that we have a lot of Kotlin. And then again, we wanted to leave that white paper link for you all to read and hopefully share within your companies. Next, we'll be speaking at KCON in March in Germany, and so we hope to see some of you there.
So now we've walked you through the 8 key techniques that we use to drive change at Intuit. First, finding what you're passionate about, socializing the idea, talking about it with your teammates, and sharing out your favorite features of that new tech. Then creating a proof of concept to really drive the key points of why you think that tech is so amazing. creating a plan so everyone's on the same page on what goals you want to accomplish, the timeline for it, and the impact for your specific team. Then persuading with data, finding those data points to prove your argument even more. Deconstructing the myths on different preconceived ideas that people have in their head that aren't necessarily true. And not stopping there, keep going. Even when you get some issues, you gotta push through it. And then connecting with the larger community to share the knowledge even more and grow as a community. So we really want to tell you that it's been a great experience for us. We've been able to reach so many people, and it only takes 2 people to start a movement.
Thank you.
Thank you.
Well, hello everyone. I'm very happy to see you all on this beautiful conference. It's in fact the first time I attend such large conference. I've attended a lot of them, but this is the largest so far. And as you can probably see, my name is Alexander Nozik, and I want to make a confession. I'm not a programmist, actually, at least not officially. My job title is called Senior Research Scientist, and I work at laboratory, Nuclear Physics Method Laboratory at MIPT, which is the most prominent physics institute in Russia, and also in the Institute for Nuclear Research. And from this year, we also are members of JetBrains research community, which I am quite proud of. And my PhD thesis is dedicated to neutrinos. So let's talk about neutrinos. Do anybody know what neutrino is? Please raise a hand. Oh, a lot of people, at least half of, that's a lot of people. Maybe we should discuss physics. And it's actually about the mass of neutrino. Neutrino is a very hard to detect particle because it passes through Earth without hindrance from the sun and from extraterrestrial objects, and it's very hard to measure it. It's very hard to find it. It's very hard to know its qualities, like fundamental qualities, like mass. But still, how many neutrinos are around us? Is it relevant? And in fact, it is. If you take this room, for example, even not a room and your seat, you have billions of neutrino from the sun passing per square centimeter per second. And you can multiply it by the surface of the room and get the number of neutrinos. Neutrinos are everywhere, like Kotlin. But the problem is, so as I already said, it's very weakly interacting. So even if you want to measure it, to capture it, you need to create something like this. I'm not sure you see the scale. It's a people here, and this is a detector. It's called Super Kamiokande. It's located in Japan, and it's a 40 meters by 40 meters vessel filled by water, and a numerous number of super high-tech detectors, photo detectors, which are used just to see the effect of the neutrino. Otherwise, as I said, it passes through the Earth. You can't. You measure it from in the night because you do not need to see the sun for that. It passes through the Earth. But this is typical. Yes, it's not all, because in order to measure it, you need to measure it deeply underground. This experiment is located about a kilometer or more underground in the mine in order to cut all the background. And even small experiments like my home experiments located in Russia, Troitsky mass experiment, it's tiny by experimental physics standards, but it's still, you can see it's pretty large. Man could fit somewhere here. It's small, but when you try to rotate this vessel with the iron bar, I've done it when I was a student. It was quite tiresome. So neutrinos. We can talk about neutrinos, but we won't. You can definitely ask me about neutrinos during breaks, and I will happy to share my knowledge. But this conference is not neutrinos, it's about programming. And specifically, not the general programming, but programming in science, in natural science to be specific. Let's consider the science from the programmer's point of view. We have a lot of things we need to do with the software, computers. We need to do simulations. We need to know how our particle will interact before we create experiment, because it's huge, because it's quite expensive, super expensive. And you need to know what you expect. You need data acquisition, a number of detectors, a number of systems, and of course you need analysis. Everything requires a very high level of software, a lot of different software, and reliable and flexible software. So what we actually need from software is a high performance, because we have a huge amount of data to analyze and to simulate, and it's quite computation extensive. We need the flexibility, because we have a lot of different tasks, and we have to have interoperability, because we have different teams working on different projects in different language and different ecosystems, and it should be somehow connected together. It's not like you work in bank and you have a closed software and you have your own team. We have a distributed team across the world. And the main problem is that scientists in general are not good programmers. It's a fact, because they learn science, they learn physics, chemistry, I'm not sure, computer science as well, and but they do not learn programming. So it's a byproduct. They usually do not have a lot of expertise in programming. It's a really problem. And what are the requirements for our tooling, which we use to create this software? We have some requirements. It should be quite simple to learn, because they are not good programmers. They can't learn complicated things like Haskell. I don't know. It should be safe. They are not good programmers, because so if they write a code, it could break any time, and the less it breaks, the better. It should be universal, because programmers nowadays learn at least 2 or 3 languages. It's normal. But for physicists to learn even 1 language is a serious task. So if you ask him to, you should learn Java, JavaScript, C, and something else, they say, no, I won't. It should be fast. I mean, not the language fast, but the compiled code should be fast, because we work a lot with the heavy computations. And by heavy, I mean those that takes months in modern computers, and even huge clusters. And we need to have libraries, of course. We can't write everything from the scratch. It's obvious. And so the major language in at least high energy physics is a C++ nowadays. And what's wrong with the C++? It's a super powerful language. It can do everything. It can allow you to do these low-level optimizations, and new standards are coming almost every year, bringing new features. And CAP, you can work with these libraries like TensorFlow or something like that easily, because C++ was designed this way, and you can see a lot of different possibilities. But C++ is very complicated to learn properly. You have to spend a few years learning it to use it correctly. You can start to use it, but there is a high chance that you will use it in the wrong way. And it happens. Exactly, this happens. It's unsafe, not only from the memory point of view, but also from the language point of view. Refactoring code in C++, especially in bad C++, is very complicated and very tiresome, even for a qualified programmer. And the modularity is very bad problem when you have different teams working on different parts of the project, and with C++ modularity is not quite good, and it complicates the problem even further. So I don't want to say that C++ is a bad language. I believe it is, but I won't say it, not to make someone angry. But at least one should be a professional developer with a few years of expertise to properly write in C++. I do not think everyone will argue with that. Now, people start moving to Python. And Python is a superior glue language. It was designed as that, and has bindings almost for everything, and very easy to write these glue scripts using high-performance codes from C, and something from Java, and something from network, and etc. Does not require build setup, which is important for many physicists, because they're not programmers. They just run it and it works. I found this pretty picture just before the talk, and I think it shows why people using in science, why people are using Python, because you have all the features, but you have a high-level language to work with them. But still, there is a limit of scalability of Python. You hit the wall at some moment. Dynamic typing and other design restrictions, in fact, you are limited to NumPy, because if you go outside NumPy, the performance drops tremendously. So you do not have the Python. You have a very tiny subset of Python, very limited subset of Python to work with. Do you know what happens if you write the actual Lambda in Python? It compiles. It is not compiled. It is interpreted in runtime, so the performance is terrible. Even if you have a lot of code written in correct NumPy, one Lambda function somewhere, and it is super slow. And of course, in Python, there is further problems with the scalability because of these builds and these environment-driven builds, and it's very hard to run the complex program in Python the same way on two different setups if you do not have Docker container. And so, wrong button. So still it is the most popular language for non-developers, and it's okay. We are teaching students in Python, physics students I mean, but it is bad for development. You are very restricted by it. So what's wrong with a lot of other languages? C# is good clone of Java, but it has its limitation, and I think the main problem is, no, I've written it's no scientific library and small ecosystem. Rust is a very good candidate, but Rust sadly requires programming expertise. You need to understand what you are doing with all this borrowing concepts. Julia is a good, better Python language, and it has its potential. But for now, the dynamic typing, optional dynamic typing is a problem, and the tooling is really bad for now. I'm not sure it could improve in the future. I won't talk about JavaScript. I won't talk about Go, Dart, etc. Swift, there is some effort in the scientific community to move to Swift, but I think we've got better options. What's wrong with Java? Java is super good. Java is super, especially Java 8, but there are some complaints, slow startup time, and increased memory consumption. It's not a problem for scientific applications, mind you, because we usually have a huge application, so startup time and memory means nothing. Need to learn a build system. This is actually a stopper for physicists, usually. You need to learn Gradle, Maven, or something like that. You just can't run it, and people say, I won't learn it because it's tiresome. It takes too much time. Verbosity, it's known, and there is a mistaken reputation for slowness. First version of Java built quite slow compiled code, so people remember this and say the Java is slow. You should know. You probably know that nowadays Java and JVM is one of the fastest thing that exists, even in the numeric intensive tasks. So we also have Scala here. Scala is complicated. Scala is good for maybe for computer science, but for physicists it's too complicated to learn. And we have Groovy. Groovy had a chance as a better Python, but it did not fly. I'm not sure why, because it's pretty good language. I'm not sure why it did not work, but it did not. And you probably guessed it already, yeah? So let's talk about Kotlin. Kotlin is a superpower for many different tasks, like Andrei Breslov said in the keynote. It's a universal language in different ecosystems and different platforms, and it has several superpowers. Of course, we need to remember that we're mostly talking about Kotlin JVM, and it somehow inherits some of Java problems, like build system and startup time. The verbosity is gone, and reputation is also gone. It's still the same platform, but physicists do not remember that it's the same platform. It's new language, so it's fast. Okay, it's faster than Java. Oh, okay, let's forget about it. It's just a psychology. So there are few superpowers of Kotlin which I want to, in application for science, which I want to discuss. First of all, Kotlin is a better Java. Better Java, so I'll show some examples. Better Java, so let's consider this application. It was a small and really simple simulation of muons. Muons are another, who knows about muons? You know about it? Oh, a lot of people know about muons. Super. So deep underground, there are only neutrinos and those muons, also some neutrons from the caves, but mostly neutrinos and muons, and they make this background in the underground laboratory. So there is a detector which is now used in Spain, I believe, if it is not moved to Finland, and there was a simulation to understand how those particles propagate through the detector, and there was a Java and JavaFX code to do the simulation. Pretty simple code, in fact. It's nothing complicated. And it works, but it was rewritten in Kotlin completely. And it works, but looks much better. It's less code, it's more concise, and everyone's happy. But otherwise, it works the same. Of course, it's a reason to adopt Kotlin, but not a significant one. Another application, it's much more time-consuming one. It's as I already showed you, this Troitsky mass setup. It's for measurement neutrino mass, and until recently, these limits were the best in the world for a few years. So not so small in the end. A lot of things to do, read out from devices using TCP/IP and direct device reading, data storage, data acquisition, data indexing, communication protocols, very, very complicated analysis. It's a tiny experiment, but analysis is one of the most complicated in the world. And pretty much a lot of lines of code, about 100,000 lines of code, and only me, to maintain it. And I've done it. So try to maintain 100,000 lines of code in C++ or in Python. So, as I said, safe and maintainability is very important because we have long projects, not 2 years, not 3 years, but tens of years. So maintainability is very important. And yeah, I wrote it, lambda syntax and some language features which improve our code. And what is important for this project was a gradual migration from Java, because we have a lot of Java code and we partially replaced parts of the code in Kotlin, and it still worked like it should. It's not important for most of projects because most of them are not written in Java, sadly. Another superpower, and I personally think that extensions is the main superpower of the Kotlin, not the nullability. Is the extension and scope and functions. And what I want to show you, some things we were doing in our laboratory last year. And first of the problem, let's consider you want to write a generic numeric operations. I hope everyone understands what's the question. So for example, many-dimensional arrays. Python people like many-dimensional arrays. So there are different solutions to the problem, to apply types to those arrays. One solution is to use specialized version for each primitive type, like it is done in C, in Fortran, and in fact in NumPy it's done the same way. A lot of code, a lot of duplicated code, but it works, and it works fast. because you have a specialized versions for each primitive. The problem is even not the amount of code, but low maintainability. If you need to add something new, you need to add something new to all of these primitive types. For example, you define new operation. I'm not sure which one. You need to define it on all types, on all primitive types, all composite types like complex numbers, etc., etc. It's very hard to add something, and it's very hard to fix something if something is broken. So those libraries are mostly done and not touched anymore. The Java way is to use generics, and it's much more simple to maintain, and it's looks. I wrote it not in Java. I wrote it in Kotlin, and even better because you have these operator functions which are very beautiful and allow concise code. But still, there are problems here. One problem is boxing. Do you know who do not know about boxing? Wow, everyone know about boxing. Super. When I talk these slides to physicists, most of them do not. And in fact, there is another problem here. I'm not sure who see it. Does anybody see another problem here? It's hidden. No, it's not a problem here. The problem is, I will show right now. The problem is that in order to define plus operation for those, you need a plus operation defines for those. And this interface does not give you any way to define operations for this generic type. It's the problem. It's real a problem. So it's a standard question. Do you know the result? Yeah, you know the result. It's a little bit boring. Yeah, it won't compile because number does not know about plus operation. Double knows, but generic number does not. And it was a decision done by Java development. It was a correct decision. Why? Because if you add plus operations for numbers, then the result will depend on the order of operation, which breaks the contract. It's not good. So that's why in those systems we do not have plus operations defined for number. But it brings a problem. How can I operate on and here I have numbers, and even if I have some raw generic type, I can't just take these plus operations from somewhere. I need it defined in types somehow. Yeah, and what if you add new type for which you do not have this operation defined? There is some solution to this problem outside Java. For example, C++ and Julia do it by adding some code during compilation. For example, in C++ generics, this will compile on in use side using types from use side. But of course, it will be not safe because it will fail if this type T does not provide plus operation. And Julia probably will work as a dynamically typed language. It will just in time compile this expression, and the same it will fail in runtime if type do not provide plus operation. It works, but limited type safety and huge tooling problems because IDE can't infer which will work and which will not. So what about Python? Do you know the result? The result will be strange, in fact, for people who are not who do not know how Python works. It will be junk, some garbage data, because I have initialized this array and it inside calls native array initialization, but I did not fill it, so it will be random whatever in the memory. For Python people, it's okay; they know this pitfall, but for people outside Python, it's a little bit surprise. And another problem is if you have this in the array. Python does not have type. Yeah, we add just a complex to this many-dimensional array, and Python actually has types. because in fact it's not Python, it's a C underneath. If you understand it, you understand it. But if you are working Python, you will be surprised because it does not work. And of course you will find only in runtime. Now, what extension add to the plate? Now you can add the functionality you want as an extension. You do not need to write it inside the class anymore. And so if you add some new entity to your code, some new mathematical construct, you can just define those operations by extension, and which is much more important, the extension dispatched statically. So this one will be numerically optimized for double. Compiler knows the type when you use this thing. For example, you can define this plus for in the array of double, but not defined for in the array of complex. And it will work and will be numerically optimized for double, and the performance is extremely good. So this is very important thing about extension. And it worked like Python, but without monkey patching. But let's go further. Let's separate operations and values completely. Consider this a lot of code here, but what I want to point is this. This is a context of operation. I say everything inside these brackets is done on complex numbers. So I can define functions which operates on complex numbers inside this scope and do not leak those operations outside. So outside, I do not know about those operations, but inside, I know about them. Let's see how it works. This complex field just defines the operations. It does not define the state. So you separate the state, like complex number as a data class or something like that, and you separate operations into the separate class. And you define those operations like these. These are just neutral elements to field in algebraic meaning. You define this mathematical construct, field is a mathematical construct, and define it in the language. And then you define operations inside these mathematical constructs. Of course, we would like to move those to extensions as well, but for that we need multiple receivers, because we need this as receiver and double as receiver at the same time. I really need those. If I can get this T-shirt with I won't keep 176, I will definitely get it one. Let's return here, and we define complex operations here, but let's go further. As I said, we want to define many-dimensional arrays and operations on them, and again, why not define the... We already exist in these complex fields. Now, all of what I need is define many-dimensional array of complex numbers. It knows its context, so it propagates here, and we have inside this context, we have many-dimensional arrays of complex numbers, just like that. Only inside this. And then, of course, we have some very, very nice Kotlin features like defining extensions inside your function. You can add functionality which is limited to your own scope, which is very, very important for numerically intensive computations, because you do not bloat this code base and you limit the scope, and it's really very convenient. And again, it's statically dispatched, so no impact on performance here. And we have some operations just like in Python, with only 2 additional lines of code. And as addition, you have, for example, type safe inversion operation, because it could be done only on 2-dimensional structures, and I need to explicitly check that it's 2-dimensional. By the way, I think this example could be modified, so this one with 2 arguments always provides 2-dimensional structure. I will think about it, and it is safe. I think that Breandan we'll talk about it later. This expansion of this idea later this evening. Okay. Some further reading, and I've wrote some articles about it. You can read it there if you want. And the repository is open source, of course. Additional bonuses from Kotlin. Of course, coroutines. Coroutines are very hard to even understand how much do they bring to the ecosystem. For few examples. For example, this one, which we will start next year, consider this particle. If the particle flies, and then it interacts, and then it interacts more, and then we do not need to propagate any further, and we need this simulation. And in reality, we have pictures like this. This is rather obsolete. It's bubble chamber. They do not use them anymore, but it's beautiful. And this is a simulation from actual simulation from Atlas experiments, which is one of experiments and Large Hadron Collider, not far from here in Geneva. Propagate. The workflow is following: you propagate a particle. Compute cross-section, compute interaction point, generate children particle, and propagate those children particle. Everything is straightforward. But now, let's do it in parallel. Then there are problems. The number of children is not known in advance. The depth of each branch could not be estimated from the beginning. And if you try to apply traditional tree traversal algorithms, they will fail because you do not know tree where you start the traversal. Most of those algorithms are based on the fact that you know tree from the beginning. You do not know. You create it as you go. And also we need, if we go in parallel, we need to store some track-specific information like random number generator seed, because the process is random, but sometimes we want to, for example, make a reproducible simulation when you put a seed and it's the same each time we run, and do it in parallel. The order of computation is random, so you can do it in a reproducible way. And hurrah for coroutines, you can do it. This is not actually working code, it's just some kind of idea how it could work, that you compute this interaction point, you see extensions here, then you make those are suspended functions, those are coroutines, and you put this algorithm I've written earlier, this one, here just as it is in coroutines, and then all that I need is to launch this function as inside some kind of coroutine context. And even more, I will get that depending on the context, I will have a different computation. In single-threaded context, I will have a single-threaded computation. If I put here something like dispatcher's default, I will have multi-threaded computation. If I put here some kind of cluster context, they are not exist so far as far as I know, but they are possible. You have automatic clustering out of the box. And it is even possible to do some continuation computation remotely. It's discussed right now, but it's possible. I'm not sure when it will be applied, but it's possible to resume computations here on the remote computer and make it completely distributed application. So it's superpower. We will also have the automatic back pressure, because if we have some I/O operation in the end, for example, we need to drop the data to the disk to save it. We have automatic back pressure, so we do not lose the data. And this I already told about. Yeah, no global state. No, not an actual code, but we have running prototypes for these kind of things, and I hope the next year we will implement something like this. Additional thing is data acquisition and slow control. It's a thing who was working on some kind of data acquisition and slow control, working with devices. Nobody here, okay. At least something to surprise with. it's not as simple as it seems, because it's just write string to the port, read string from the port, and store the data. It's more or less simple, but if you see the scheme, it's not that simple, because you have a physical state of the device, and you exactly read, write, but you have also an intermediate logical state of the device, which communicates with your network, database, etc., etc. And the simplest communication diagram looks like this. You make a change for some, I don't know, close the valve or something like this. Then you send synchronous command to your device. Then you get synchronous update. Then you dispatch message to the network. And there are also asynchronous updates. If you do it in traditional means, it is rather complicated, but it just asks to be written in flow. Nobody done it before, but we will try to do it. And next year we're starting it with Tango controls, international collaboration. We will try to apply some things from Kotlin, even from Kotlin Multiplatform, to this framework. And at least, the last but not the least is the multi-platform. And the main problem for scientists, one of the main problems for scientists, is proper visualization tools. So, oops, wrong button. So I'm sad because all good visualization tools went to the browser. I used to write them in JavaFX and TornadoFX, and it's good, but only a few tools left for the desktop development. Most of them I went to browser anyway, and we have some ways to solve it problem. We can learn JavaScript, but we can't. We are scientists. We can learn more than one language. No, won't work. Or if we already know Kotlin, surprise, we can learn Kotlin JavaScript, which is pretty the same Kotlin with tiny differences. And we can move all our visualization logic to the front. Just make a common application and move this visualization part on the front end. And it seems to be okay, because we do not need to learn completely new language, completely new ecosystem. We are inside our zone of comfort. An example, a very preliminary example, is a library we written last year. It's a Plotly KT, or Plotly Kit. I like to pronounce it this way. Do you know Plotly? Everybody knows Plotly, probably. It's a very prominent Python library for drawing plots. And we wrote a very simple wrapper for basic functionality of this Plotly library, and wrote this backend server which translates actions we do in this JVM. It creates a server and serves both data and updates for this plot data, and dynamically renders this thing. The API looks like this. It's pretty concise. And it's type safe, which is important. Plotly is JavaScript, it's not type safe. And even in Python, it's very hard to write because it uses a lot of maps with the keys inside. So even in Python, it's very hard to write properly in Plotly. But in Kotlin, it looks really great. And in fact, it uses some very experimental thing, because we do not use those data classes or something like that, fixed classes, to translate our code into this JSON and send. Instead, we use dynamic typing inside and wrap it with a Kotlin extension, so it looks, extensions and delegates, so it looks like it statically typed. I do not have time to explain it properly. You can just visit repository, and I had an article on this as well. We can discuss it later if you want. But it's very experimental. I was not sure it should work this way, but it really worked, because we get not only this simple serialization, but simple dynamic updates and automatic diff generation as well. The thing we were actually done because of JetBrains research funding is the tool which allows for 3D visualization of events in the experiments, like collider experiments, where you have two nucleus, hit each other, a lot of tracks, and you need to visualize both geometry and those tracks in the 3D. It's only in a prototype, but there were some problems, and we solved them, and we had a lot of prototype geometric primitives to render, configurable elements from the model, and a lot of the main thing is we have to work with the legacy code and transform models used in particle physics into something which could be used in modern application, and the application is actually multi-platform. For now, we use only a 3JS renderer because we focus on that, but we have stubs for other platforms as well. I mean, desktop and maybe native in the future, I'm not sure about. Bridge to native world is a very important thing for scientific application, because we have a lot of legacy code written in Fortran C, and the JNI is very expensive and hard to do properly, and the SWIG is outdated and also hard. So Kotlin native, okay, it's already fast. When I've written it, it's maybe not the fastest, but it's fast enough. But it has a very good compatibility with the CRP, and it seems to be rather logical to write in Kotlin native or use a Kotlin native as a bridge to native world and interact with all those legacy libraries. Well, there are also other examples like Kotlin statistics library written by Thomas Nield. I believe he was in the KotlinConf last year. And of course, you should visit Breandan report later this evening about Kotlin Grad library. Oh, I do not have a lot of time, so I will be quick. Not everything. Everyone asks me what are the problems of Kotlin. Boxing, you know about boxing. I won't stop here. A lot of problems by boxing. If you have a primitive and nullability, you have boxing. If you have a primitive and a list, you have a boxing. And you have a primitive and a lambda, you also have a boxing, because under the hood, lambda is just a function generic type double, which means boxing in most cases. This is a problem which Kotlin brings, which Java did not have, because in Java it's double from a small letter. And you know the type exactly when you describe the function. In Kotlin, it also will be the problem because of this. I think it will be solved from the in the compiler somewhere in future, but for now it's a little bit problematic. I think you should know about them if you want to avoid them. C++ interop, I already solved it. You can use either wrappers or you can create a bridge to native world via Kotlin native. And this bridge somewhere around Copenhagen. And yesterday I read that there is a massive data cable inside it, so probably it's proper here. Visualization is a problem because scientists want something very simple for their visualization, and they are very sad when they can't do it this way. Python and Julia ecosystems made an extreme effort to solve this problem, to add proper visualization things. But in Kotlin, sadly, still nothing. There is some effort from Data2V's team, but I'm not sure it's enough and fast enough. We need to expand this. But in Kotlin, it's not hard because all the visualization tools are JavaScript. You just need to write binding. So let's sum up. It took a little bit longer than I expected, but let's sum up. Kotlin is a potentially next language for natural science because it solves most of the problem with other tools. And its interoperability with Java is very important because we have all those libraries, all those many years of experience and the optimization. And it's quite safe and it's quite simple. And new features like coroutines and multi-platforms are very important, but there are still issues. For example, we still have some minor performance issues which could be solved. We do not have those visualization libraries or some easy access to libraries like don't know, TensorFlow or something like that. We need extensive library and wrapper support for them. And there is still a question about easy native interop. I think if either of those problems is solved, Kotlin will rise dramatically in scientific in the mind of scientific community, because really it's good. It has a really good prospects. So thank you very much. I wanted to reserve some time for questions, but
So, hi everyone. Please take your seats. Actually, thank you for coming, and I didn't expect you to be so many people here, but thank you so much. I hope you'll find something interesting during this talk. So today we'll talk about how to build microservices with Kotlin and gRPC. And usually when I start this talk, I ask people if they're familiar with Kotlin. I'm not sure that this question is relevant here, but please raise your hands if you know what Kotlin is. So I really like you. You are the best audience. So the next question, if you're familiar with gRPC. Oh, too many people. I don't know what you're doing here because I'm not going to talk about some hardcore things, but I hope you'll find something interesting. So a few words about myself because I'm here for the first time. It's my first Kotlin conference. I'm a little bit nervous. So I'm a software engineer at company Wix. Maybe you've heard about this company, but if our advertisement hadn't reached you, I'll tell our marketing team, and you'll probably see our advertisement in YouTube. So Wix is a great company, and because even without knowing some technical stuff, even without any degree in computer science, you can build a website for yourself and earn some money or do whatever you want. And actually, we try to change lives of people. So this company is great, but my talk is not about my company and about all the stuff we are doing here. It's actually about my experience, and all my thoughts are only mine and not my company's. A part of working full-time at Wix, I am also an active community member. I organize Kotlin user group, Kotlin Night in Kyiv. I'm also in program committee of different conferences. So if you're interested in, you can follow me, you can ask me, And I also write some posts in Medium, and you can also follow me on Twitter because sometimes I post some funny stuff. So one really important thing you should know about me, I do boxing. I like it very much, so think twice before asking tricky questions. When I did this joke a couple of weeks ago in my company, where we mostly use Scala, one guy said that now Kotlin team make this aggressive marketing. Yes, and I think that we should, because Kotlin is great and we should be more aggressive in propagating it. Of course, it's a joke. I won't hit anyone, at least today, because I am in a good mood. So let's proceed. Today we'll talk about gRPC in general, what it is, because half of the audience still don't know what it is. Then we'll implement some very simple service, and then we'll re-implement the service using coroutines, and we'll understand how we can benefit from it. After that, I'll show you some cool libraries, especially for Kotlin and gRPC, and explain you how to use them and what can be done with them. So before we start, the talk is sounds like building microservices with Kotlin and gRPC. But in the very beginning, if you started your career 10 years ago, 7 years ago, or even earlier, you probably wrote monolith. And I think that a lot of people are still writing monolith. But in some point, in some moment, a big monolith split it into many, many microservices. So in the very beginning, it was a monolith, and then we started doing microservices. So please raise your hands again. It's like a workout. If you're doing microservices today. A lot of people, you're really progressive people, because at some conferences, just 2 or 3 people say that they are doing microservices. But today, microservices is a really huge trend. Why? Because it's rock. You see, I'm a hard rock girl, and I like rock. Why? Because we can be independent. We can do whatever we want and in small parts. And one microservice can be written in Kotlin, another in Java, another in Scala, in Python, Go, Rust, whatever you want, and it will work together. Sounds like a magic. It's scalable, because scale small parts is easier than scale big parts. Like if you're scaling big monolith, it's quite expensive. But if you're scaling some small parts, you can be more flexible. You can decide which microservices you need more instances, which fewer instances, and you spend less money. You can choose best suitable tool, as I already told you. We can develop something in Node.js, for example, another microservice in Kotlin, and be happy. And of course, we can do parallel development, because if our teams, some teams are working on their own features, we just define the contract, some interface, and then teams are working independently and in parallel. And of course, it makes our company to earn more money, to develop quicker, and be happy, and et cetera, et cetera. So microservices is really cool concept, and I think that it's like it can help us very much. But we cannot talk only about pros of microservices. There is one but, one big con. Let's talk about it. The biggest issue in changing a monolith into microservices is changing the communication pattern. What am I talking about? When we are writing monolith, like a few years ago, and we are just triggering another service in your server. It's like your own method and another function, and it's like under your hands, and you can easily use it. But when you split your monolith in a lot of microservices, like at some point you understand that you have network. A network is something that is not reliable at all. So it's something that could be down at any time and you can do anything with it. Also, if you're using network, you have latency. So if you just trigger another service on the same server, it's okay and it's quick. But if you're using network, you add some latency. And it might be not that good. And of course, communication makes writing microservices a challenging thing. By the way, do you know who said this? Any ideas? Okay. He is a cheater. He saw my talk. Yeah, it's Martin Fowler. And if you don't know this guy, you probably should find him and find his articles, his books, because he's really smart and he has really smart thoughts. So we are writing microservices, most of you, but what do we use for writing microservices? Most cases we are using HTTP1 and REST. So please raise your hands if you are doing this. Don't be shy, it's not a sin. Actually at Wix we are also using REST and HTTP1. Not like everywhere, but we still have these parts. And it's not bad, so it works for us, it's okay. Why should we use something else? But for example, at Wix, we faced one small problem. We have 150 million of clients. I think at this point it's 160 million of clients. It's millions of requests per day, per second, per minute, and we need to handle it somehow. And we need to buy more and more servers and to pay more to Google Cloud, to Amazon, and it's all about money. It costs money. And the more your company pays for your infrastructure, the less it pays to you. Are you happy with it? Me not. So I think that I want to earn more money and to reduce costs of my company for more infrastructure. And we decided to think about something else. Maybe there is a way to reduce our costs in some point and to spend less money on infrastructure without changing a lot in the code. And here comes gRPC. gRPC is not the only solution, but it could help. So let's discover what it is. I have a riddle. Do you know what gRPC stands for? So you probably should understand that it's an acronym. Maybe you know how to what does it mean? Yeah, most people think that it's Google Remote Procedure Call, but surprise, it's not true. It's a recursive acronym, and it means gRPC Remote Procedure Call. Actually, I had the same fellow facepalm and think that what the hell it is. And then Google guys, they decided that it's not good stuff. And it's not true anymore. So then they said that for each new version of gRPC, they have new meaning. Maybe at some point they just will like run out of words starting from G and okay, it was funny stuff. We know what's G, but what the hell is RPC? Do you know what is RPC? Actually, RPC is not a new concept. It's a remote procedure call. What does it mean? In simple words, it means that you have some function, some interface that you can use, and it is your own. It's written somewhere in your code. But under the hood, it's something written by another one, and something could be on another server and another site. And under the hood, you're using network for calling it. But you think you treat it as it's your own function. There were different implementations of gRPC, like Corba, RMI, and people were not really satisfied with it because it was complicated, the code was ugly, and they don't like it. And actually, gRPC for many years was not good stuff. But gRPC, developed by Google, is the same RPC, but with really cool interface. So you can, it's friendly, you can use it, and you can write like simple, elegant code, and that's why it's getting its popularity really fast. So let's talk about its features. Why gRPC can help us to reduce costs, because we need to understand how it works. First of all, gRPC is built on top of HTTP2. So do you know what is HTTP2? I'll tell you a little bit about the protocol evolution. In 91, we had HTTP 0.9. Then 96, it's 1.0, 97, 1.1, and then no progress, no progress, no progress. Maybe they're not alive. Yeah, I think they're dead. And suddenly, in 2015, HTTP2 appeared and said, like, I'm alive, I'm still here. Of course, it's a joke. It doesn't mean that they did nothing for the whole decade. But what I'm going to tell you that everything changed. Like the whole life changed, the whole internet changed, and we really need something new. But if we look back a few slides ago, we can understand that most of the people are still using HTTP1, which is not that good because it's the protocol from 96 year. By the way, do you know that HTTP3 is appearing? It's going to be soon. So we probably should switch to HTTP2 or HTTP3 soon. So using HTTP1 is not cool today. Think about it, please. So why HTTP2 is so cool? First of all, finally, we can have single TCP connection. So in HTTP1, you could have keep alive, but it was failing at some point, and it was difficult to work with it, as I remember. And finally, HTTP2, we just keep this single connection, and you do not open new connection for each request, which is quite optimizing. Then you can have, as you have this connection, you can have bidirectional streaming. So you can use this connection for streaming, and not only for server streaming, but for client streaming, which is quite revolutionary. Because even with WebSockets, you still can do this with client streaming. Also with HTTP2, you can do flow control. Just you can define how many requests you can handle from your server, because sometimes there are problems with it. I think that there are a lot of Android developers here, and you know that mobile phones are not that smart and not that cannot handle all those requests as, for example, my laptop. And it's quite good to have this solution to say, server, please send me a bunch of requests. I'll cope with it, and then you'll send me more requests. So flow control is a really cool feature, not to make your client down and to keep your clients satisfied. OK, that's enough with HTTP2, because we can talk a lot about HTTP2, but our talk is not about it. So gRPC also supports multiple languages. As I already told you, you can use Kotlin, Scala, Java, you can use Go, you can use JavaScript, TypeScript, C#, whatever you want, even Python. And one of the main features of gRPC, which really makes it cheaper and can reduce your costs, is binary. Because HTTP2 protocol is finally binary, and protobuf, which is used in gRPC, is binary protocol. So now you are not sending strings using HTTP1, but you are sending bytes using HTTP2. And bytes are cheaper than strings. So it works. In Java, we have implementation for gRPC. And Java really likes gRPC. I know a lot of people who are using Java and gRPC and are happy with it. In Wix, We also decided that gRPC is cool enough, so we can try it. We tried gRPC and we like it. But there is a small problem at Wix. We have Scala. And so it's not a small problem, it's a big problem. Okay, so Scala is not supported like officially by gRPC. We only have gRPC Java, but there is a really cool library called Scala PB, which makes writing gRPC in Scala even not that painful, but even better than with Java, because Scala PB adds a lot of features. You can use futures and all Scala asynchronous stuff and be happy with it. And if we can do this stuff with Scala, we think maybe we can do this stuff with Kotlin. And that's how actually this talk appeared and how I started investigating this. So we discovered a little bit gRPC. Let's proceed. I've told you that we are using protocol buffers for for transferring data in gRPC. So let's talk a little bit what is protobuf. So protobuf is Google's language natural platform natural mechanism for serializing structured data. So in simple words, it's like XML or JSON, but smaller, faster, and simpler, and so on. Why is it so? Because in protobuf, we have this pseudo language, and we can define this file. So you just write protofile, and your protofile, you define your service. For example, we have service greeter. Here, do you see it? Yeah. And you have method say hello. It's RPC call. And in this method say hello, you have hello request and hello reply. And a little bit lower, after the service, you define what is hello request and what is hello reply. So in our case, it's just string, but you can have a lot of different fields there. So in just like, you're just writing like some code, and then you define this protofile. It's compiling, and then you get implementation of this, like not implementation, but you have these classes compiled in the language you're using with the plugin you're using. So you can compile it to Java, to Go, to Dart, to Ruby, C#, whatever you want, and so on. So let's a little bit summarize what's protobuf. Protobuf is type safety. Why? If you are talking about a Kotlin or Java or another static type language, you can see that you have classes also in your static type language. And you cannot violate these classes. So if you are passing something else, you have compile time error. You also cannot violate schema. For example, it's quite difficult to send in say hello, no, not hello request, but some integer or something else, because you get compile time error. So you cannot violate it because it's a compile time check. As far as we are working with binary, it's bytes, it's fast. So serialization, deserialization is fast. And one of the coolest feature of protobuf is backward compatibility. If you want to add some new fields into your messages, you can add it easily or deprecate easily because all these fields are optional. And it's quite good because at work I'm doing it all the time. We all the time need something new. We need to deprecate something old. And it's quite easy to do this because of backward compatibility. But the main problem of protobuf is lack of human readability, because if you are debugging it and at some point you need to understand what was sent, you just get bytes. And if you can't read bytes, you're in trouble. So that's enough about protobuf. If you want, we can talk more about it after the session. Let's implement some service, because I'm talking a lot. I see you're a little bit tired, or not. So we'll implement this. As you can understand, I am a big Star Wars fan. You see, my friends are here. So, and today I decided that I need a Death Star. I need this tiny little Death Star to destroy universe. So there is a small task for this session. What should we do? First of all, we need to write this Death Star. And then we need to destroy as many planets as we can. Then we should tweet about it, because if we don't tweet, think that it won't happen. So you should tweet. And I'm a little bit lazy person, so this demo is already running somewhere in the cloud, and you can play with it. And 2 winners will get these prizes. So if you are a Star Wars fan, you can win it. And of course, enjoy. I hope you'll enjoy it. Application is here. If you want to play, just actually, I didn't expect that I'll have too many people here. So I'm not sure that our server will handle all this stuff, but shit happens, so sorry. I hope you'll have fun. Actually, there is a really smart algorithm, so not every planet can be destroyed easily. You need to to put your effort there. So I think I can proceed with slides. Yes? So let's look forward. And now I'll explain you how this application works. In this application, we have 2 main flows. First flow is when user join. When user join, you or me, I will go to the star service. It's my first microservice. And the star service goes to planet service and asks how many planets and which planets do we have in our solar system. And then we have a response, and we notify our user to paint our universe. So that's how the first stuff goes. And then we want to receive some logs. What was happening, who joined, who destroyed something, and we subscribe for logs. So we go to log service and have server streaming from it. And then we go to score service in order to see how many people joined, how many people are playing, and their scores. And asynchronously, we are receiving these server streaming results. So we are subscribing to log and score service and receiving results asynchronously. It's when user joins. The most interesting stuff is when user destroy planet. So when you click on planet for many times, and at some point planet was destroyed, we send a request streamingly into the star service. If planet was destroyed, we are going to planet service and remove one planet because it was destroyed. But we are a little bit cheaters because we don't want our universe to die at all, and we generate a new planet. So we send this new planet to our service, and then we log everything, update scores, and update our user asynchronously. So your screen is repainted asynchronously. Let's implement this. First of all, we need to start with protofile. Here is our protofile. We have the star service, one method destroy, and you can see that in this protofile, we have this keyword stream. It means that our destroy method is bidirectional streaming. So we are sending requests, like stream of requests, and we are receiving stream of requests. And it's a cool feature of gRPC, because you can do this bidirectional streaming even using only one call. And here are messages. Planet, like planets, and destroy planet request. And then some magic, and all the stuff is compiled to Java. Unfortunately to Java, because we don't have a Kotlin plugin officially, and we need to use gRPC Java and build something on top of gRPC Java. This code is a little bit ugly, so I don't want to make violence to your brain. I just show only declarations and won't show you what is under the hood. If you want, we can talk about it later. And we need to code something, and we have this server. We define this server, and we see that in this server we need to add service in order to make our service work on this server. And this service is called the star service impl. And we need to code, and now I need to return to my code. Oh, so I am a little bit lazy. I am a little bit scared to do live coding because all the time when I start in live coding, I forget how to type. I forget everything. So I'll just show you what I have, and we'll explain it. So when we're using gRPC Java, you see it's about gRPC Java, what do we have? We have this destroy method. First of all, we subscribe. So we add our observers to listeners in order to receive updates about what's happening in our solar system. Then we need to paint the whole our universe for the first time, and we ask our planet service to send our all planets there. So we are getting all planets, and you see that we need callback here. And in this callback, we are doing this with our response observer. Okay, as far as we have bidirectional streaming, we need to do we need to return stream as well. So what are we doing? We return stream, and in stream, in callback, what we are doing? We remove planet. If planet was removed successfully, we are doing again a callback, and what are we doing again? We're updating scores, we log, we generate new planet, and after new planet was generated, as far as we want to reuse this result, in the callback, we log everything, and we notify all our listeners that our solar system changed. So I don't know if this code fits my screen. Yeah. Okay, we implemented. Let's return to code. Well done, yeah? You see that something strange here. So there is a big problem here. Please put your hand on your heart and say if you like this code. I can't do this. It's ugly. It's like I don't want to write it. And if people say me that I need to write it every day, I just better shoot myself in the head than write it. Because you can see, and what's disgusting here? There is disgusting silhouette, which I hate. And this situation is called callback hell. Because all the time, when we need to reuse a result from previous call, we need to send a callback there. And it's like stupid, because callbacks is not what we need here. We are using Kotlin, we want coroutines, we want this better stuff, we want to live in better world. So, first question, why don't we use futures? So it's obvious and we can do this, and even with Java we can use something reactive, or I can use completable future. So why don't we use futures here? And we can do this. Let's return to our code. So I just wanted to show you how ugly it could be, but it's not that bad. So yes, I'm doing this cheat again. So what do we do here? We launch coroutine here. Not that global scope is not that good. You'd better use some another coroutine scope, but it's a demo. So don't do what I do. So what I want to show you. We do the same stuff here. We send in get all planets, and we send in these all planets to our response observer. But what's happening? Our stop is now future stop. You can see that it's future stop. And now we have this method await, because this is future, and we can add some extension, and we can have method await here. And now you can see that this is a suspension point, and this function is suspend. So now we have this result of all planets. We don't need any callbacks. We just can send it to our response observer. Then again, we need to return stream, because we are working in bidirectional streaming. And after that, we do the same stuff. We remove planet. We are reusing result. Again, we have suspension point. We destroy everything. We generate a new planet. And again, we don't have any callbacks with new planet. We just make straightforward code. So it looks much better. So it looks this way. And please raise your hand if you like this code. Remember about boxing. So this code is not that bad as it was, but it's not that good that I want to use. So here comes gRPC and coroutines part 2. Because it's not enough only to use futures, we need to have something else to get rid of this stream observer at all. Why? Because we are Kotlin developers, and what do we have? We have channels, and we have coroutines, and we can use them. So the problem is that it's quite difficult to do this. We need to implement some bridges on top of this, and we need a hero who can do this. And first hero who I found was gRPC Kotlin. This was quite an interesting library, which was really easy. And actually, some part of my demo is written with gRPC Kotlin, and it works. So let's go into code and find how we can use this. So, sorry, here it is. Yeah. So again, I'm a little bit cheater. So what do we see here? Here, we do not have any returning of stream observer. We have this cycle. Why? Because for now, we do not have stream observers, we have channel. Our requests are received channel, and we are returning also received channel of planets. So we generate this channel, and we are iterating all our requests. So we are using it as it is some collection. We are iterating over it with cycle 4, but under the hood, we have coroutines and suspension here. So it's more straightforward and more declarative way than it was with stream observer. So what do? Again, we are removing planet, we are adding scores, we are logging, and we generate new planet, and we notify everyone. So now code looks this way, and raise your hand if you like it. Don't be shy, because I don't have a better solution for now. So what I like about this code more than about previous, we only see business logic here. There are much less boilerplate here. All line of code do something smart, do something for business and not for infrastructure. And that's what we want in Kotlin. That's why we switch from Java to Kotlin. And that's what we need. And our Dart trader is happy. But wait a minute. I lied a second ago because I have a better solution. We have another hero, and another hero is Krota Plus. It's one more library. It's really huge and interesting library, and I think you should probably look into it. And even an author of this library is here, and I'll show him to you. So we have another hero, Krota Plus, and let's look in code how it looks. So it looks pretty similar to previous one, but then we see that there is, we do not return channel. We have this request and response channel in parameters, and that's why we can eliminate some problems with some hanging channel, and yes, and we can have less code here. And you can see that even here, we have even less boilerplate than before. You can see. And again, we are doing the same stuff. We are iterating our requests. We are removing, we are adding scores, we are logging everything, generate new planet, log, and notify everyone. So code looks, with Krota Plus, code looks this way, but it's not the only feature of Krota Plus, because you can extend and you can even write your extension for how you want to compile your protobuf, and so on, and you should definitely look into this library. So now the story method looks this way, and I even like it more. So please raise your hand if you like it as well. Yeah, I think I had a small workout during my session, because all the time you need to raise your hand. So if you all become fit after my talk, it's my thing. And let's talk a little bit more about libraries for Kotlin. When I started looking into this stuff a year or more than a year ago, I thought that Kotlin is so cool, gRPC is so cool, and I probably have these cool, amazing robots who can save my life, who can do everything for me. But then I found out in reality that we have this kind of guys that can't really shoot anyone in 8 episodes. Why? Because it was a year ago, and not a lot of people looked into gRPC and Kotlin. So first thing that I found out was gRPC Kotlin. I was really happy to find it, because I thought that it's official from Google because of gRPC Kotlin. Then I found out that it's in someone repository, and it's version 002. And there is a message that it's a prototype, so don't use me. I was a little bit sad because I wanted to use it in production, and but I was said that it's not smart. And I just looked into it and decided to write my own wrappers for the gRPC and Kotlin. But in few months, I found out that it's version 012, and I liked it. Because it was really a huge job done for this library. And now my demo is almost written using gRPC Kotlin. So I hope it works. And I really like it, and because it's very simple. And if you just want to have some simple stuff for gRPC in Kotlin, you can use this library. But if you want something more, there is Krota Plus. When I first come into this library, it was quite interesting for me. But again, it was 0.13 version. And I didn't know how it will be released, and so on and so on. But today, see that there is a Slack channel. There is version 0.50. And for now, I think it's going to be released soon. And there is a logo. And it's really an amazing library. I think you should probably look into it. And you can see the message that community contributions are welcome. So if you want to make it faster to release, if you want to make it better, to make life better, so you should probably contribute there, or maybe write your thoughts how you see this. And I think people who develop it, who contributed in that, deserve applause and deserve some thanks to them. So some useful links about from my talk is some repositories from Salesforce, is gRPC Java Contributor Reactive gRPC. It's even if you don't use Kotlin, you're with Java, but you don't want to write this ugly stuff, you can look into these libraries because they implement some stuff with completable features, with reactivity, and the code, even in Java, is not that ugly. There is also a protobuf library for PB and K for Kotlin. It's quite interesting. I tried to use it at Wix, but it was not. We had some problems with it, but it's not because of this library, it's because of we have Scala. But actually, this library is really interesting. And if you want just to use protobuf and Kotlin, it's okay to go there and to look into it. And then, of course, I have link to my demo. If you want to play with it, want to add something, want to fix bugs, so your contributions are welcome. And one more stuff, the last link is about performance. At Wix, we still don't have these benchmarks, how gRPC helped us or not. But I know that guys who made this investigation, they had some interesting results. And if you're interested in it, you can look into it. So when I started doing this talk, all the time, I said that one day we'll have a stable Kotlin support, blah, 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 because libraries were not released, and I didn't know about the future. But today, for the first time when I'm doing this talk, I'm saying that we finally have a stable Kotlin support, and you can use it in production. And I think that soon, a library like Krota Plus will be released, and you can use it. And I can say that it's really cool. So time to summarize. First of all, you can use gRPC for effective communication. Even if you don't use Kotlin, if you use Java or even Go or TypeScript, gRPC can help you. So you should not ignore it. Then, if you want to use gRPC in Kotlin, you can understand that things will be easier than with Java. So you should look into it. So gRPC plus Kotlin can be used today, and you can make things easier. We're waiting for first release of Krota Plus, and I think that we should add flows there. And I hope it would be even better than with channels. And feel free to contribute, of course, because it's open source. And people who are working in it, they have their daily job, and they don't have much time to work on it. And your contributions are really welcome. And the last point, don't use gRPC. What am I talking about? I'm talking a lot about gRPC, how it's cool, how it can reduce your costs. But the main thing that I talked about Wix, about our company, with 160 millions of users, with millions of requests per day. And yeah, we need gRPC because it can reduce our costs. But first you should think if you really need it. Because if you have one customer and one request per month, maybe it's okay to live without gRPC with REST and so on. So you should think if you really need it for your scale and to reduce your costs. Because benchmarks say that if you don't have high load, you don't need gRPC. As I already told you, we need to define the star master to give this presence. So let's look into demo. I hope it's working. Oh, lots of people are here. So, Daniel Weber and Jonathan Ward, you should come to me after the session and decide who takes what. Okay, so after the session, just come to me. And it's time to say thank you. There are a lot of people who are behind me, who helped me to make this presentation not that ugly. And first of all, it's Ray, who was developer advocate for gRPC and who pinned me in the right direction and showed me right people and right repositories. And these two guys are authors of Kotlin gRPC and Grotto Plus. And they did really cool job. And they helped me a lot. And I really appreciate the job they did. And of course, my slides. Here are my friends who reviewed my slides, who helped me not to be afraid of you, like this. And this guy, do you know who is he? Yes, you're my favorite audience. There are some people who don't know who is he. It's George Lucas, yeah, his father of Star Wars. And of course, thank you for sitting here, for having me here, and thank you.
Where's the camera? Here. All right. Welcome, everybody. Welcome to Bootiful GraphQL with Kotlin. I'm Guillaume Scheibel.
And I'm Dariusz. We work at Expedia Group, which is a leading travel platform, and that includes a number of companies besides Expedia, such as Vrbo, Hotels.com, Orbis, Travelocity, and many more. We've been building GraphQL APIs in Kotlin for the last year and a half. And in the next 40 minutes, we're going to attempt to show you how easy it is to build a GraphQL server in Kotlin using some of the libraries that we open source as part of this effort. But before we get to the demo, let's take a step back and take a look at some of the technologies that we're going to be using today. So as the title implies, yes, we're going to be using Spring and Spring Boot. Probably you heard about it. It's a little less known frameworks, but Spring Boot aims to simplify or speed up your bootstrap your application development process, right? It's built on top of Spring, and some other libraries, and it provides you auto-configuration libraries that eliminate a lot of the boilerplate code by providing you some, well, predefined defaults, right? There are a number of auto-configuration libraries available for pretty much any technology out there. And Spring Boot also makes it very easy to create a custom libraries if you need to as well. Today, we'll be building a web application. And since it's 2019, we will be using Spring WebFlex, which is a Spring reactive web framework, which allows us to build a fully reactive, asynchronous, non-blocking web application. Today, we're also going to be using GraphQL, which is a query language for your APIs. It is a specification that defines how to expose your data in some specific format that is not only easily discoverable by your clients, but also allows them to select only the data that they want. The data is exposed through a schema, which is a collection of documents that defines what sort of operations are available to the users and what sort of data they can query. GraphQL schema is also strongly typed, which means that every single field in it has to be resolved to either some primitive value, such as string or integer, some enum, a complex type, which contains a number of fields inside of it, or a list of those objects. Interestingly enough, GraphQL also makes a distinction between nullable and non-nullable types. So when you define your schema, you have to also define whether the field is nullable or not. And that constraint is enforced at the runtime. It is also important to note that the GraphQL itself does not tie itself to any specific database technology, nor some storage engine, right? It's up to the developers to decide where they get the data from. So they can call some web services, the databases, generated randomly on the fly, and GraphQL is only tasked with exposing it in specific format to the client. When we're actually working with traditional REST-based APIs, right, we work with resources by the means of some URLs, right? So we may have an endpoint for users, right? We may have another one to fetch some product. Maybe we have another one to fetch some reviews data, which works great if you have a single client, right? You can have a very optimized response to that single client. The problems arise when you have more than one client, which all have slightly different use cases. Some of them require parts of the data, others require some additional data, maybe others require a combination of those different resources, right? GraphQL solves this problem by exposing a single endpoint, generally just /GraphQL, that accepts a query where clients explicitly specify the data that they want. This allows you to build a single API that's very flexible and custom tailored for each one of your clients. So for example, you may have a desktop app, right, and a mobile app, and they all both can request some common subset of data, right? But on the desktop, you have a little bit more of screen real estate, right? So maybe you want to fetch some additional data to display that to the user as well, right? And finally, well, we also got Kotlin, right? Kotlin is awesome. It is a great programming language, right? It has a number of awesome features. That makes it a pleasure to work with, right? But there are a number of GraphQL implementations out there, right? So why choose Kotlin to build your GraphQL APIs in it, right? The first and foremost, it is strongly typed and also has a null safety built into the language. You don't need any third-party libraries to get this information out. This means that you can build your Kotlin data model that's going to match exactly how your GraphQL schema looks like. Once you add in like the data classes, it allows you to eliminate a lot of the boilerplate code as well. But that's just a nice to have feature. At Expedia, over the years, we built a number of Java libraries, right? So for us, ability to just call those libraries and use them as they were, it was also a must. So your mileage may vary on that one. And last but not least, well, coroutines are also great, right? They allow you to write asynchronous code in an imperative way that it's not only easy to understand and reason about, but also makes your code more maintainable. So if we combine all of those together, well, we got GraphQL Kotlin. It is a set of libraries that aims to simplify how you build a GraphQL Kotlin server. Today, we're going to be using GraphQL Kotlin schema generator, which, as it's hard to guess, it's about generating a schema. When you're building a GraphQL server, there's actually two ways of how you can approach it. You can either start with schema-first approach, where you manually craft out your schema and then map it to your code somewhere out there and hoping that they're going to match. That's the traditional approach. And alternative approach is, well, your code is a source of truth, and you generate your schema based out of it. With GraphQL Kotlin, we are following the code-first approach, and we use reflections to automatically generate your schema directly from your source code. Your source code is your source of truth for all your business logic and the shape of the schema. This allows you to also write the code the same way as you were for traditional REST APIs, right? You write functions, they return some data classes, and it all just to get exposed to the schema. But schema is just a part of the few things that you have to configure in order to have the GraphQL server. Well, besides schema, you also need a runtime to process those requests, right? You need to also have some additional, some endpoint to accept the incoming request, HTTP request. And potentially you may want to do some like exception handling, et cetera, right? That's a lot of boilerplate code that you gotta, well, keep copying over and over again to every single application, right? That's why we also created GraphQL Kotlin Spring Server, which is a Spring Boot auto configuration library that pre-configures all of those beans for you. It's easily customizable. And without further ado, why don't we check how it all works in practice?
All right. We are developers here. So the first thing we want to see is code, right? First question, is it readable at the back of the room? Or do you want me to make it bigger, right? Awesome. So Spring, if you want to do a Spring Boot application, we have two ways, Maven or Gradle. Both are awesome tools here. I'm going to use Maven. If you're familiar with starter.spring.io, like the basic scaffolding you can have with Spring, in that case Spring Boot 2.2, and Kotlin, you would have in your POM file a parent, right? Nothing fancy here. Then you would have at the bottom the dependencies, the plugin for Spring Boot and for Kotlin. That's pretty much it, right? The only thing we add on top to getting started is a single dependency here, our auto-configure library. As Dariusz mentioned, GraphQL, Kotlin, Spring Server. And from a dependency perspective, that's all we need. That library will bring Webflux, will bring a bunch of things like this to make everything available. In terms of application and Spring Boot code, the only thing we need is this. We can't make anything simpler than this. With Spring Boot, we have all the defaults, all the auto configuration. Like that's just the bare minimum we can have to run some Spring application. And we just need one single configuration, which is just the list of packages. Why do we have that? Very simple. As we mentioned before, we are generating the schema from reflection. If you expose something like, I don't know, java.lang.local, you might not want to serialize all that together, right? You might want to expose that as a GraphQL class. So with this, we are just restricting, when we are building the schema, where the classes that are going to be exposed outside can come from. In here is going to be just that package. You can have a list if you want. There is no problem with that. And that's all you need to get started. Now let's write some code. So if I go here and I say we have a conference query, we're going to have a class, let's say conference query, in the traditional REST world, you would do something like this, REST controller, right? And then you would have some get mappings, post mappings, and so on and so forth. We are not going to do that today. All we're going to do is to say component. That's the classic like bin declaration from Spring. And we need to have just one interface, which is query. Just going to remove this. The reason why we need query is just for the schema generator, or for GraphQL Spring Server to tell the schema generator, these are all the queries you're going to work with to generate the schema. In GraphQL, you have queries, read, mutations, write, and subscription for streaming. And so we would have the same exact same interface, which is basically just a markup interface for mutation and subscription. We don't need anything else than this. Now we have that. We are going to start coding with a function. Let's say I want to expose some conference, which is basically a conference. It has a name. Let's say KotlinConf. Oops, sorry. And a year, which is 2019. Data modeling, as you can guess, and I'm pretty sure you're familiar with this. We can have name as a value here, as a string, and we can have then a value year, which today is going to be an int, and actually a nullable int, right? And here I have already, with that simple part of code, all I need to do to run my server, and we can just click run, right? So anything very fancy, we're going to pick up the conference class. As you can see here, we by default put the, or dump the schema in the console, so you can start see a type conference. But you know what, let's run some queries. We come up directly in GraphQL Spring Server with something called the playground, which is basically a much better version of Swagger, right? So Swagger is kind of bulky. Here I can just say, I have a schema, so I have my documentation. Let me just reload this. Here I have my documentation. I can say, we can query for a conference, which has a type name. You will note here the exclamation mark at the end of the type. That means the field is not nullable. Year, if you remember, in Kotlin, I put the nullability, which means that then we don't have the nullable part, right? It's a bit confusing at the beginning, having explicit nullability, non-explicit nullability, but after a while, you just get used to it. And so because I have a schema, I can do something like this, which is simplistically autocomplete. So I can have my conference, and then I have to specify all the fields I need to select. So in my conference, what can I have? I can have a name, I can have a year, and that's all I need. Like I type effectively all the fields, no wildcard, which is super important because then we can be explicit and we can be much more performant. When I run this, as you can see, I have, as you expect, a conference with the name, the year, and I know what I get because I have schema, and I get what I want because I select all the fields. Just think about a mobile app on a not so great 3G connection somewhere, right? And if you're returning a bulky and super complex JSON payload where it only needs a tiny bit of things, either you're going to spread your services and duplicate your logic, or you're just going to pay the price of latency. With this, I have one API, and I create exactly as a client what I need. Not more, not less. So that is super interesting already. Once we have something like that, we can add a couple of stuff to our conference. First off, documentation. We all love documentation. We all hate documentation at the same time. So here, the same way you have with OpenAPI, I can have a GraphQL description, which is just here, in that case, a simple annotation or some places to learn things. And I'm just going to do this. As you can see here, I'm using a markdown syntax. That's because Playground, in my case, can just interpolate all the description as markdown. So I can have like links, I can have something very rich. even I can do multi-line and so on and so forth. I'm not really limited there, and I encourage you to add a lot of documentation. The other thing we can do is on the year, I can say it's deprecated and not needed anymore. Restart the server. So we have added the capabilities to basically pick up the add deprecated from Kotlin, and GraphQL already supports that kind of feature, which means if we look back here at our schema, we have the description in the schema. That's a by the spec feature of GraphQL. Same thing with the deprecation here. It's in the spec of GraphQL, which means that if I go back here, I just reload. We can have here in the documentation, if I just go down, look at the name, and yes, the name is just here, awesome place to learn new things. You can see the nice markdown interpolation. We can see that here we have already, just in the documentation itself again, the fact that a field is deprecated. And finally, that's the cool stuff, because it's in the schema. If I reuse here, you would see, and that's something that even clients can do, obviously. If your client library is capable of doing it, you can have the deprecation information straight in the schema. In terms of resource management, it's just awesome.
So this is actually a very powerful concept, because since every client explicitly asks for every single field that they're interested in, you actually have an insight what fields they're actually using or not. They're also, like on the client side, right? If they actually have the queries, it's quite often they may not be updating their queries, right? It's actually, I don't know if schema changed, but during the build tool, they can configure their tools to actually fail this schema generation when they're actually referencing the deprecated fields as well. So there's a lot of powerful tooling around that as well.
All right, so now we have a first class couple of fields, not very complex things here. Let's move on to a bit more data modeling. Nothing fancy, nothing too complex. Interfaces, Kotlin interfaces, right? We just have a name. We have two data classes. So we have attendees, all of you here, attending a conference where we have a ticket type being an enumeration of values, and we have speakers with names and a list of talks. So just like that, and it's very similar developer experience as you would have with most of the REST frameworks. You can just have all your modeling like this, and it would work exactly the same way. So if I go here, we just do something like this. I can return easily my list of people. I can have attendees, I can have speakers, and let's see how to query polymorphic types. Because that is something that is built in the GraphQL specification, right? So if you're using GraphQL, Java, Go, Elixir, Kotlin, obviously, you will have support for polymorphic types. So here I go back, just reload so I have the latest schema. And I can say I have some people. The way to describe, so people is a list, remember? Here I describe the way I want, the fields I want for each and every elements of the list. So, because people, the only thing we know about people are names so far, so we have this. I run my query and I have Jane and Guillaume coming back. That's effectively what we expect, right? Two people came back, no problem. First thing to notice is I still selected in my field my conference, and I'm selecting peoples. If you think about a RESTful application, and even more an 8OS design, you will have a lot of calls to achieve exactly the same thing. Here I had one HTTP request going down to my server and bringing me all the values. Again, performance-wise, it can have a huge impact, especially when things are complex. But people, we had attendees and we had speakers. So far, all I have is just a list of names. I have to be more explicit. I have to say, like, all right, if the person, or the people in the case, is an attendee, then, oh, now I have access to ticket because I'm strongly typed, I'm type safe. So I can have the ticket. At the same time, if I have a speaker, guess what I can get? The list of talks. Here, we're just going to zoom out. And now I get all the fields. I'm strongly typed. If you have a strongly typed client language, let's say TypeScript, you can generate classes from the schema and having all those kind of things, plus null safety on top of it. It is just a pleasure to work with that kind of system, to build APIs and to build contracts. Right? So that is pretty cool. Now if we go back to our code, we're just going to add one more feature here. We're going to say that we have a name start with, it's a string, and I want to have that as a nullable argument. Meaning that if I go here, I will have just it.name dot start with, name start with, and doing something like this. So because I have a function, I can have arguments in Kotlin, which means that then when we reload our schema or our application, it's going to take a bit second. There we are, just reloading this. First off, let's look at our documentation, which is right here. We see that in GraphQL, you can have arguments, and in that case, nullable arguments, right? So if I have a nullable argument, it's exactly that case here. There is no argument for people. So I can just say this, brings me back my two attendees, my two people. And then if I want to say start name with, and I would say G here, just return, I just have Guillaume. That's effectively what we expect. And that is pretty awesome, right? We can specify, we can filter, you can do whatever you want with arguments. It's definitely a great power to have, right?
Yeah, so when we're talking about polymorphic types, right? So interfaces are very useful when you have some common shared traits between the different objects, right? But sometimes you may want to return something that's completely disparate, right? They don't have anything in common. So maybe like some search results and maybe some error response, right? So the GraphQL also gives you an option to create what they call union type, which is basically very similar to the interfaces, just you implement it as a marker interface without any shared fields. That's about it.
All right, let's move on a tiny bit. Now we've seen basically pretty much 95% of schema design in GraphQL. So you're already experts in GraphQL just by knowing how to type some Kotlin code. That's pretty cool. Let's move on with something a bit more fun. So here we're going to create another class. Like we had data classes, conference people, and so on and so forth. We're just going to have something like this, which we could expose the same way right here. So if I do something like this, right, I expose a schedule, where I have a greeting and my list of talks coming, something like that. That's very easy, and frankly, it doesn't represent quite close what we would have in the real world. So in the real world, what we might want to do is to fetch data from other sources, services, databases, caches, name it, it's up to you. So we are just going to, instead of returning directly something hard-coded, we're going to move a tiny bit, removing that from here. Then I will just go back there. And so we know how greeting and talk as two properties would work. I mean, same thing we had with title and year before. But there is interesting behavior to notice is this one. If I take my talks and I just move them to something like this. So just going to resolve this, just the logger from SLF4J. I can have talks not only as a property, as a value, I can have talks as a function. And just as I mentioned, here a simple, like we're going to retrieve our talks from the cache and from a database, which if we are thread blocking by default would look like this. So you would see something very quick. Obviously, we are not going to implement the full call here, it's just as an example. A bit of log, returning a value, same thing there, like nothing really complex, right? Here we are just getting the list of our talks that are cached from the database, putting all them together, returning them. And we're going to see how that works. And see that there is an interesting pattern between functions and values with GraphQL Kotlin. So I'm just going to move here the logs on the side and moving that here. So if I have, we're just going to remove all this. I need to reload first, obviously. So we have here the schedule. We are going to say greetings. I mean, that's what we expect, right? We just return the hard-coded value we had. No dark magic there. But if I start returning my list of talks, remember, we have a bunch of logs, we have a bunch of things, and we start to see logs appearing right there. Okay? So interesting behavior. When I have fields, everything is returned at the same time. When I have values, basically, it's basically POJO serialization. However, when we have functions, and each field in theory are independent, the function will only be invoked when I'm selecting the field, right? So if, as again, a mobile app on a very bad 3G connection, I'm just interesting to the title, because I already have the list of talks like in memory, I can just do this. It's super fast, right? If I want the list of all the talks, obviously I would go back here, and that will start to take time, and that's the way I can basically have a better performance gain just by changing a value to a function and to resolving that function, because I have that gain in performance, and that's already a big thing, right? Why would I pay the price of, in my case here, 2 seconds of latency, while I just need greeting, which is basically hard-coded? That doesn't make sense, and that could be basically have a huge impact. I just showed you, we are returning, or we are doing everything on thread.sleep, which means that we are blocking, and that, again, is not great. So we are just going to have a look at this. I'm going to do this. First thing here to note is I selected Scheibel twice, talks twice, grading twice, but only once in the response. So if I just put that back here, it's more readable. And that's because, by default, if I select the same field multiple times, GraphQL will just say, no, we're not going to overly compute. We are basically going to stay where we are. And again, all the fields, all the functions are resolved independently from each other. So if I want to run the Scheibel twice, let's assume I have an argument that will filter different things. There is a technique called aliasing. So I just give here this one a pretty name. That's only client-side. The server doesn't really care about this. And here I would have S1, S2. I run that. And it takes quite a lot of time, as you can see, but I have my 2 schedules at the same time. The reason why we are taking quite some time is if you look at our logs, let me just start over again so you can have a bit more view. It takes about, let's say, 4 seconds, a tiny bit more than 4 seconds. And effectively, we have one thread being used that basically prints in the serious way, the first list of the logs, the second list of the logs, and yeah, if we look, it took basically 4 seconds between 33 to 37, right? The reason why is our programming model at this point is based on threads. So the HTTP request comes down, takes a thread from the web server, and then we run all the computation on that thread. Even though, in theory, we should invoke all the functions asynchronously and in parallel, we cannot because we are bounded by one thread. And guess what's the way to solve that problem? To have true parallelism, coroutines. So we are going to move a tiny bit of code. Now that's thread blocking, I don't like it. We're going to do thread non-blocking, and just moving here to delay, and obviously suspending our functions, right? So we can move to the coroutine world by doing something like this. Here, I want that function to be suspendable as well, to have its own coroutine scope, right there, don't need this. And I want, in my case, but that's then up to you to manage your coroutines as you wish, I want to say, here I have an async, I have an async here, a tiny bit of this, I want to return that, and last but not least, we have an await there, and an await here, and just with that, I move completely my my runtime, my server, to a non-blocking and async way.
You need the return.
I need the, oh yes. Keep forgetting that return. Keep forgetting that return. That's why we are two on stage. So now we have our application. First thing, before running queries, suspendable functions, functions over properties. From a GraphQL standpoint, it doesn't matter. I managed to refactor, from a performance perspective, my application quite a lot. Yet, my client, because I didn't change the schema, don't need to change anything whatsoever. My contract, my abstraction layer, aka the schema, is still the same. From a perf perspective, let's see how that looks like. So, you know what? We didn't do that during the practice, I know. We're just going to do 3. And just to see if there is a difference. 4. Again, remember, we have 2 seconds, a bit more than 2 seconds per computation. So if I'm completely wrong, we're going to take about 8 seconds to resolve this. Otherwise, it should be 2. Let's try. 1, 2, and there. Tiny bit more than 2. So see, we have true performance in everything. Thanks to coroutines, thanks to the programming model from GraphQL, we resolve everything in parallel. If we look at our logs, here we can see that we did a bunch of stuff completely in different orders, on completely different threads. I mean, 3, 3, 2, 1, and so on and so forth. That is truly a coroutine way to do things and a reactive way to do things. We are not bounded by one thread. All right. So here we are doing a bunch of cool stuff. Now there is a slightly more advanced feature in GraphQL, and effectively with GraphQL, Java, and Kotlin, called a request context. Sometimes you want to have access to HTTP information, let's say a header, to get the language or to get a user token or something like this. And you want to have access to that information during the life cycle of your application when you resolve fields, right? For example, I would like to internationalize the greeting message based on the accept language header. To be honest, it's not that great to have the HTTP request or the HTTP response sometimes being accessed in the middle of the application when you're resolving a field like this. That's why we have request context.
And furthermore, in GraphQL, you generally have to be very explicit in what you're asking, right? So the queries, you specify all the parameters, but this is actually implied from the HTTP request that it's not part of the actual query that you're sending, right?
All right, so here I have my a new class, a new bean effectively. Nothing really complicated. That's something that is, you remember the auto configuration part brought from GraphQL Kotlin Spring Server. That's why it works. Because then GraphQL Kotlin Spring Server, we should find a better name. It's too long. Is basically going to pick up a GraphQL context factory, and that factory can return any class you want. In here, I just expose the list of languages. Nothing really complicated here. And how do I get that list of languages? Here I have access to the HTTP request. The important part with that kind of thing is when I do something like this, I have 4 GraphQL subqueries that will be made for S1 to S4, but I have 1 HTTP request, which means that even in a case like this, I will have 1 request context being created for the whole life cycle of the HTTP request, right? Not more, not less. So when I have something like this, then we can do some dark magic. I want to basically internationalize this, and we're just going to make some space. And we're going to do something like that. So you will notice a new magic parameter at GraphQL context, basically being the class I created before with just the language. And that's all I need. Because it's a add GraphQL context, there is that annotation, it's not going to be on the schema. That is just for you, in your app, in your server, to do some things. And once I have this, then I can do whatever I want with this. I can have other arguments, which may or may not be in the schema, that's another thing, and so on and so forth.
And GraphQL context is accessible from any place in when you're executing the GraphQL schema. So any function and as many level deep as you need. So you don't have to keep passing around from the top level down as you would normally do in some cases.
Yeah. So I just here removed the greeting argument I passed from the beginning. Coming back here. The thing I want to show you again is here there is no argument about GraphQL context. You will note that basically the logger is not there because it was private. The cached and the database functions are not there because they were private. If you want to not expose some functions that have to be public for whatever reason, at GraphQL ignore would basically tell the schema generator just say ignore that field or ignore that function. No problem with that whatsoever. And so when we have something like this back, here I already have, actually not this one, that's another kind of info, don't care. So let's see how that works. Default behavior, about in a second, here I have my greeting in English. And if I move back to here my HTTP header, so accept language, and I say, I'm going to accept French today. Rerun this. And bienvenue is now my greeting. So I have my request context used the same time everywhere. No problem with that. I can have access to meta information, again, languages or user tokens or whatever. All right.
So hopefully by now you can see how easy it is to build the GraphQL Kotlin server, right? It's we just require a single dependency, right? Configure one single line of the properties, right? And then you just implement your code as it is, right? We do have a lot of other examples and as well fairly extensive documentation available on our GitHub repo. And well, follow us on Twitter for our GraphQL journey. And well, thanks everyone.
We have a
Hi, all. My name is Breandan Considine. I'm a graduate student from Montreal, and I'm here to talk today a little bit about the research that we've been doing and some interesting things I learned along the way. If you have any questions, the organizers asked me to make sure you raise your hand and so you can get a mic. So there's 5 things I'd like to try to talk to you about today. What are derivatives? Maybe this will be kind of a little bit of recap for you if you went to Eric's talk. How does differentiation work? How can we implement it on a computer? What can we derive when we have this? So what things are possible to get, and what are the conditions for differentiability? And how can I do this in Kotlin, of course, because we're here at KotlinConf. And why should you care? What's the big difference? It seems like maybe kind of abstract, but it seems like there's a lot of people here, so that's kind of interested. That's exciting. Yeah, so what are derivatives? This is kind of a long and storied history. We kind of have a short period here, but this goes back kind of hundreds of years, as we heard. It has quite a bit of invention and reinvention. So we'll just kind of touch on 3 figures along this way. So you kind of look back, kind of the end of the 1600s, the end of the Renaissance, start of the Enlightenment, starting to look at, how can we formalize some of these models that describe physics and the world around us. And kind of an interesting character was Leibniz. He had some very contemporary views about minds and machines, and I think if you went in a time machine and went back and wouldn't be, or brought him here, they wouldn't be completely out of place. He's got some interesting things to say about computation and cognition and lots of things. So you can kind of look him up on Wikipedia if you care. So it's kind of fitting that we're here in Copenhagen because this is one of the places in this history that is kind of interesting. So more recently, in the Northeast European Computing Center, there was a bunch of computer scientists, and one of them was Seppo Lindema. He was a Finn, and he came down here for his master's degree. He was studying how to analyze local errors and how they propagate through a long program. And so as the story goes, he's sitting in a park here and came up with this algorithm, which is today known as reverse mode automatic differentiation. And so this is right here. It's kind of cool. And he's a professor in Helsinki. A lot of these ideas were kind of studied and popularized in the 70s and 80s. And people were looking at larger scientific simulations. And so this idea has broad applicability. And maybe you hear a lot about it now in machine learning and optimization literature, but this has a lot of applications. And so if you're interested in learning more about those, I highly encourage you to check out this book from your local library or order it on Amazon. It's got a good history and a lot of techniques that would be useful for what we're going to talk about today. So let's see. I would like to motivate this with a few examples. So to kind of take a step back, we saw a little bit about optimization. And so let's think about an algorithm for minimizing a function. This can be any function that you so please. As long as the outputs are comparable, we have some way to say if one is better than the other, then this algorithm will eventually get the minimum. So we pass it a budget and an initial kind of guess. And let's say we give it 100,000 time steps. And depending on the the size of the input space, this will eventually converge to the global minimum if we give it enough time. Now, maybe we don't have that amount of time, but here we have, our base case and the recursive case here, where, if we pass an input to the function, we get something that's less than the current minimum, then we pass that forward, and we record that as our minimum. And we decrement the budget, right? So all you have to do is implement this kind of random sample. And if you do this well, then this might be a perfectly good algorithm. You might like how it works. So we'll leave that exercise to the reader. But it has some nice properties in that we don't care about what type of input it is or what type of output it is, as long as we can compare them. Good. Okay, so here's another algorithm that's a little bit more restrictive, but it gives us a little bit better efficiency, and it has some nice properties. So we need to define something called a metric, and there's some technical conditions for things that satisfy this. But let's just say, for now, we have these two operators, addition, subtraction, kind of correspond to the familiar arithmetic. So what we'd like to do is take a difference between two outputs, right? So we'd like to find which output is better than another when we perturb an input. So here we have the same kind of setup. We pass it a function, give it an initial guess and some budget. And we'd like to wiggle this input a little bit. So kind of perturb it. And maybe there's just a few of these, a few ways we could do this. Or maybe there's a great many. And so, but as long as we were able to do that, and we can compute this distance in our output space, then we'll be able to find which perturbation gives us the biggest bang for our buck, right? So this is an algorithm called hill climbing, which allows us to kind of do this. And it's perfectly suitable for a lot of applications. So we should kind of think of this as things that get more efficient as we make more assumptions about the inputs and the outputs. Any questions? Good. Okay, so here's an even better algorithm that makes some additional assumptions about the input and the output. If we can assume that we have real numbers, or best approximation to that, then we can do a lot more. So we need to do two additional things. We need to have multiplication and division. And these give us a lot of power for doing this type of optimization. So we can compute this here, which roughly tells us what is the ratio of a change in the output to a change in the input, right? And then when we do that, then we can just kind of iteratively update our minima until we get to something that converges. And here we don't need to do a whole bunch of perturbations, right? This is kind of nice. We only have to do, well, two, if we do this naively. We have to evaluate the function twice. And we decrement our budget, and we have all this other machinery, right? So maybe this is kind of still a little bit abstract, but this should look familiar if you recall your kind of early algebra calculus class. You have this thing called a finite difference, right? And as you make this A smaller, then you get a better approximation of this ratio. And so this is kind of a nice way to narrow down our scope and get a little bit more efficiency. But what's the problem with this? Well, first of all, if we use the naive implementation here, there's two evaluations of our function, right? And so this is fine. This is all well and good if you have one input and one output. Maybe you can suffer this cost. But if you have more inputs, then you're going to have to compute this for every input, every input. And so this grows linearly with respect to the number of inputs you have. Huh. Okay, well, maybe that's still fine, but let's say you have a number of outputs, so not just a single scalar value, but multiple outputs. And so here we have to compute the sensitivity of a change to every input and a change to every output, right? So this is a little bit worse. And so here, this is something where we really like to have a better algorithm. And so, yeah, this is kind of the motivation for why do we want to do differentiation in the context of optimization. Well, what if I told you that there was a nice algorithm that did this in constant time with a constant amount of overhead. So spoiler alert, there is such an algorithm. And let's see how it works. So yeah, this is a little bit of a recap, but I think it's important to kind of really understand how this works at a kind of atomic level, right? So here, kind of visualizing what we're computing. Again, is this this ratio, right? People have been doing this for centuries, but yeah, this is maybe something a little bit new. So this is really maybe Leibniz's kind of flash of genius. Yeah. So here, we can do this symbolically. We don't even have to do this division multiplication. See this notational innovation, I don't know what you want to call it. This is meant to be evocative of division, but really there's no division that's happening here. This is just kind of a notational thing. So you can think of this as an operator. And when you apply this operator to this function, you can think of this as applying this linearly to each of the components. So we can take the derivative of the left and the right separately and then add them together, right? And we can do this. This is kind of very amenable to a functional approach. So similarly, for multiplication, if you have a product of two functions, then you can take the derivative of the left times the right, and the derivative of the right times the left, and add them together. And so you multiply this by the original values and then add them together. Right? So this is the product rule. And then we just need one more, this chain rule. Right? So kind of, if you have a function composed of another function, this is a derivative of the left times, with respect to the right, times the derivative of the right with respect to your input. Good, yeah. So this is, allows us to recover a lot of mathematics. All you need is addition, multiplication, and their inverses. And so you can kind of just apply these rules naively to get a symbolic representation of the derivative. But maybe we'd like to do this in a little more principled way. So we have this, this nice chain rule, which gives us an expansion for each of these function compositions. And what we can do is whenever we receive a composition, then we do this expansion. So let's say you have a recursive function, and it's defined like this. There's a lot of math here. Let's see. So what we want to do is you can take the derivative of each one in the chain with respect to the next one until we get to the end of the chain. And so this is just a product. We just multiply this out. And for scalars, this is pretty straightforward to do. But where the order of multiplication becomes really important. So as we remember, multiplication is associative, so we can add matched parentheses wherever we please. But and this also generalizes to vector functions that take multiple inputs and emit multiple outputs. But where this becomes important is the order of the multiplication really matters when you have matrices. So let's think about this from a matrix perspective. So here you're doing the same thing. You're multiplying these matrices. And if you remember a little bit about matrix math, you have these inner dimensions have to match, right? And so there's these two modes, right, that they use. And if you have a large number of inputs and a small number of outputs, then really you want to use this reverse mode. And this is typically the case in a lot of these modern functional approximators. And then in the reverse, if you have a small number of inputs or a large number of outputs, and a small number of inputs and a small number of outputs, you want to use this forward mode accumulation. And so there's some nice details about this in my colleague Olivier Britt's talk last year, but this is kind of the gist of what they're trying to do. So you have these vector functions, the composition of vector functions, and you can implement this using symbolic differentiation or dual mode differentiation. So there's lots of ways to do this, but this really goes to the heart of what these modern automatic differentiation frameworks are trying to do. Okay. Yeah. So, and this reverse mode is what Seppo Lindema came up with. And so this has kind of spurred a lot of interesting innovation in machine learning and for many different subjects. But this idea, I think, is a good way to capture what's happening inside of, say, a neural network, where it has a lot of times you see this graph of connected nodes and things. But really, it's just a series of function compositions, and we can use the chain rule, just straight out of the box. Okay, so how do we implement this in Kotlin? So let's see. So just for scalar functions, let's consider this as our kind of boilerplate. We have the sum, product, and composition rules, right? And we have this data structure. We can call it a D or whatever you like. And this takes a function and applies the derivative depending on what the type of each of what the function is. And so if it's a sum, we have these left and right, and similarly the product. What are we missing here? Are we missing anything in particular? Well, if we have a constant or if we have a derivative itself. So here, do the same thing. So this is kind of sort of like a pattern match, but it's, if you're familiar with that, but it has, we just match on the type of the function itself. And so for this, crucially, you need to have a graph. And so that's the main difference between what we're doing here and this dual mode accumulation, where you kind of evaluate this at every step. So here we're just building a graph, right? And each time we apply these operators, these are overloaded. So this will create a new sum, for example, and this will create a sum of two products. This is a lot of code, but what I'd like to point out here is that we have this kind of DSL for building these data structures. We have the sum, the product, and for simplicity, we can say a division is the inverse of multiplication. So kind of want to reduce the number of operators we have to implement. And here, we try to be as lazy as possible. So if you look at these bindings, what we're trying to do is return a value if all of the variables have been bound to a constant, or otherwise return another function. So it's kind of a way to reassign variables for change of variables, or do other types of bindings. Maybe you want to have a partial application or something. Okay, yeah. So when we invoke this function with some values, we're going to return either another function or a value itself. So there's some type checking that we have to do in order to do this. And so just for simplicity, there's a few of these definitions here. It's kind of a little bit dense, but here, let's see, for multiplication, we see this, this property of matrices, right? If you have a matrix, you want the inner dimensions to match. So it would be nice if we could infer an input type for when you take two functions and join them together. However, it seems kind of difficult to do this in the Kotlin type system. However, we can infer an output type very easily. This is fairly straightforward. So each of these operators defines a functional or higher order function that takes two functions as an input and returns a function as an output with the correct output shape inferred, right? And you can define this for lots of different operators. And we try to do this as lazily as possible. And so we only do evaluation when we receive numerical values. And for everything else, we just construct a new node in this graph. And this graph is called a data flow graph. So this is a pretty standard thing. You're building a DSL. You have some data structure. And here we just store the entire graph because memory's cheap. Why not? There are some advantages to folding or collapsing this graph. But really, it's not so bad of a cost if we have a very large graph. So the benefits of this are that later on, we can refactor this graph using algebraic rules to get something that's simpler or more appropriate for a downstream task. So that's kind of nice, but you don't have to do it. But the really nice thing is that it allows us to do higher order differentiation. So if you want to take the derivative of a derivative, then it's no problem. You just have the graph. It's all there. Whereas if you collapse this, then you lose that information. And so if you only store the values, numerical values, then you have to do extra work to kind of get higher orders of this to work. Okay. So maybe let's think about what we can apply differentiation for. What can we get when we apply it? And then what are the functions that are correct? Could we apply this to any function? Or are there just certain types that we can, maybe just real numbers works for those? So maybe there's some of that. Restrictions to that. That's what we can do. This is kind of a nice quote. I like it. So again, we're kind of walking in the footsteps of giants. We have a ton of scientific literature that goes back into the early 50s and 60s about using automatic differentiation for astrophysics, computing orbital dynamics, lots of things. How we got to the moon. So this is kind of, people have been thinking about this for a long time. So there's some conditions for the types of functions you can apply this to if you want to do this in a mathematical way. So we have this definition of continuity, where if you make a small change to the input bounded by delta, then the output should not change more than epsilon. And so this is kind of a nice way to characterize. So this has to be true for all points that you're differentiating at. And if this is true, then you have a continuous function. There's various definitions of this continuity. But this is kind of maybe one necessary but not sufficient condition for a differentiable function, right? This certainly helps if we have something like this. Where kind of in computers, we have our world is really not like that, right? We have these functions that respond sharply if you make a small change to the input. It's a kind of discontinuous functions. You have a lot of step functions and things. And so when we look at the world and we kind of represent it, we have to make these kind of discretizations. And so if you ask a computer scientist, what's differentiable? Well, maybe nothing. It's all just binary, right? But it turns out that for a large class of functions, it really doesn't matter. You can do this for integers, for binaries. So maybe there's something there that the mathematicians were just too rigid in their definition. If you ask a physicist, what's differentiable, well, maybe everything. We have these discrete objects in the world, but if you look closely, these have boundaries that are kind of fuzzy. And so we can describe the world in terms of these field equations. Or, if two things collide, there's not an instantaneous change of velocity. Really, there's just kind of some squishiness there. So, so they have lots of nice differential equations for describing how this works. In the top, we have a differential equation that relates kind of potential to kinetic energy. And we have for waves and the heat and lots of fields we can describe with these differential equations. So importantly, there are classes of functions where you have to evolve the system, right? So for a lot of dynamics, you can just take an input, an initial state, and a time, say 100 time steps later, plug those in and get a closed form solution for what the state of the system will be 100 time steps later. But for a much larger class of functions, which we see in the real world, they have these nonlinear dynamics where you really have to compute the derivative of each particle with respect to every other particle at each time step, because there's no exact analytical solution for this. So this is a big application of AD, and in physics, we have these systems that are hard to solve without derivatives, and so that's a nice way we can think about applying this. Yeah, so how do we kind of take these two perspectives on the world? We have these discrete approximations and these continuous ones, and create something meaningful. Well, maybe this is a little bit of a cop-out, but we let the user decide. So if they want to apply this to a discrete function, it will work as long as they define these operators of addition, multiplication, division, and so on. And maybe this is a valid thing to do. It's a user choice. So what does this look like from an end user perspective? Well, you have some functions, and we use Leibniz's notation, but this is kind of a choice. You don't have to do that. And you can take arbitrarily high orders derivatives, and you can plot this, make it look pretty, but it's not super important to have a visualization. But we do this symbolically, and so if you have an input and an output, then you can kind of plot this in two-dimensional space, and it looks very nice. Yeah. So or 3D. So it's a nice thing about type-safe languages, as opposed to those that just do everything at runtime. We have a compiler, and so we can check whether certain operators are valid on the operands that it receives. So for vectors, if you're doing a product, you want the length to match. And so if we have literals or some form of annotation, we can infer what these should be. And if they don't, the size is a mismatch, then it just won't compile. You'll get this error immediately, which is kind of nice. I enjoy using these statically typed languages, and this is a nice way to kind of leverage those features. So we can do this for matrices as well. So if you have two matrices, you try to multiply them together, and the inner dimensions don't match, then you just give them a nice little compiler error. And the IDE can localize this, and the usability is really nice if you try it out. Similarly, we can do this for currying if you have a limited number of variables. So the idea here is that if you know the number of inputs in your function and you apply values to each of those inputs, then you should receive a value back rather than a function. And so if you keep track of these, then with a little bit of type level magic, you can receive annotation or feedback from the inference from the compiler that says if you apply a variable that's not in the function to a value, then it doesn't compute, doesn't make sense. Similarly, if you apply all the variables then to values, then you have a value back. Yeah, so that's kind of interesting, but it's still very experimental. So it's hard to make this fit into the Kotlin type system, but it works. I'd like to convey just a little bit of why you should care about this stuff. It seems like there's the world of kind of software engineering is very far from these functions that we use to describe physics and so on. But the hope is that in the not too distant future, that computers will be kind of an interface between the real world and us, or the code itself is a way of injecting some of our knowledge about how the world works. And maybe we don't know all the parameters, we don't know how to get everything right, but we have a lot of very good models about the world. And so I don't think we're going to replace software engineers, but I think that we can make their lives easier by letting them define these global structures about the dynamics of these systems and how the world evolves over time, and then maybe fine-tune the parameters. And so in order to do this, we developed like a little DSL that just a simple prototype for how you can play around with this. And it's kind of just a way to demonstrate some nice ideas that others have developed long before. But there's a bunch of applications for robotics and computer vision and so on. So I think you're starting to see more of those in your devices and things on a daily basis. Yeah, so this is also motivated by this idea of differentiable programming, where if you have a computer implements just a few simple operations, and if we have a way to propagate errors through this program, then we can change parameters and update the program itself to make it a little bit more suitable for the actual data you receive. So there's a lot of interesting research at the intersection of these two fields, kind of making computing a little bit more flexible and differentiable. So if you'd like to learn more about that, there's details here at this URL. And if you're interested in mathematical programming abstractions for other types of number systems, you might be interested in this project that does something along the same lines. Uses algebraic constructs to represent math, and then you can evaluate it later using whatever number system you like. I'd like to give a special thanks to my advisors, Liam Paul, Michaela Samilis, and Jin Guo, and Ducky Town, which is a project I worked on during my master's degree. It's applying some of these ideas more recently. So I'm very excited about the applications of mathematical computing in software engineering. And if you'd like to chat, I'll be here till the weekend, and you should definitely check out their work as well. I've been asked to encourage you to vote because it helps me, it helps the organizers, and it's a great way to improve in future iterations. So I'll be happy to take questions at this time. Thanks.
Well,
Thank you, Breandan. I think you've done a very exciting work, both with the project and the documentation. Maybe you've gone too far with the Balzano-Strasse definition in the report, but okay. I've got a question about the graph you're plotted, because there is actually, it is actually a problem, usually. Because each line in this graph is a lambda function, in fact, or function, any function. When you increase the size of the graph, you also have a lot of lambdas and a lot of, and the problem is the performance usually, because when people want to do this automatic differentiation, they also want the performance. There are different approaches, and do you have some comments about that, or maybe something you want? Your ideas how to improve it, how to solve it, maybe on the compiler level? Yeah, so typically the way we implement this, it's definitely not the most efficient way. But if you're developing a DSL, then the next step is kind of lowering this graph to an architecture of your choosing, right? So this takes a little bit more thought, but given that we have some nice compiler techniques for doing this, this is not something we attempt to do. However, there are a bunch of ideas for simplifying this graph to make it more compact. In fact, a lot of microprocessing architectures will allow you to kind of vectorize these operations. In fact, you could do this at a higher level as well. So a lot of AD frameworks will implement this kind of for scalars and then let the compiler vectorize. But if you represent this symbolically, let the user construct symbolic matrix expressions, then you wouldn't need to do this. This would be lowered as a matrix kind of variable. So yeah, I wouldn't make any claims about efficiency here, but it's just a nice way to visualize what's going on. And there's a pretty good library for doing this in Kotlin, so you might want to check that out. Graph is. In fact, I have a connected question. They say that Swift guys, some guys in Swift want to implement some compiler optimized version of automatic differentiation. Do you think we need it in Kotlin, or Kotlin is good enough as it is and we do not need anything new? Yeah, well, that's kind of, it's tempting to reinvent the wheel, right? You have a bunch of very smart compiler folks, and if we compile to LVM, then well, that's all well and good. But maybe there are some advantages to doing a higher level kind of algebraic rewriting. And I think this can be something that's left up to the user, or you know, there are lots of intermediate steps where we can kind of optimize for that. But yeah, I'd say that if you're interested in kind of techniques for compiling this and making this more efficient, that's a huge area of research. And there's a very productive community that each year kind of adds new features to existing compilers. So you should probably try to leverage that. All right. Well, thank you all for coming. One of the last sessions of the day, and very much hope you enjoy the rest of the conference.